me, I'd like to kick off with a trailer actually, because I suppose that we have some audience for this presentation afterwards, which will see the recorded version of the meeting. So I will start my presentation with a trailer I made. So how you share here? You just present, you click on present, and share screen. Yeah.
Yes.
Okay.
Yes.
Share screen sharing easiest with two modules. Blah 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 blah. Okay, just share screen.
And press the button down.
You need to be acknowledged by Christopher. This is a bit tedious, but the system is actually quite good.
You must make a click on the screen and then press the button down. You must select the screen you want to share.
That's weird. Oh, it should be sharing now, but maybe just give it a second. I'll just hit remove and add to stream. It's not really coming up for some reason, Emmanuel. It's just white. Can anyone else see it? I can't see it.
No.
Okay.
Just us 5 videos.
Try it again there.
Shall I try mine for technical reasons to see if it works in principle?
Yeah, okay. That works.
So I share my screen. Don't show the tips. Share. Firewall. Allow full screen now. Don't ask. Allow a lot of buttons to be clicked, and now you should be able to show my screen. See? Yeah, that works. Okay.
I'm going to remove that. That's a good test. You have Emmanuel, yours still isn't. Oh, there we go. Something's happening now. Might be just a connection issue. Looks like it's just slow. Bandwidth, I mean.
Are you in the university building now, Emmanuel? Or are you at home?
That looks like the university, doesn't
it? I think the picture is frozen.
Because in the university there could be stupid firewall rules for certain protocols.
Okay. Emmanuel does look frozen. Either that or he's very angry.
Now, we never tested this, unfortunately, from all locations.
No.
Can you see anything still? I'm sharing the video. Can you see the screen?
Now we can hear you again. You were offline presenting a bit like a minute or so.
Yeah, so maybe if you stop talking, maybe that's why you loading the bandwidth here. Yeah.
Okay, I can mute everyone except for you.
So
yep, yeah, that's it.
Okay. Good man.
If needed, we could also stop our camera streams.
Good idea. Is there audio on that video, Manuel? Hello?
So, okay. So, can you see me now?
We might need to repeat that we had no audio on your video for technical.
Yeah, good point. Was there audio on the video? Sure, probably not. Sure, we'll move on anyway. We've got
So
we'll move on to the presentation, I guess. If you want to, do you have a?
Yes. Okay. So can you now see the PowerPoint?
Yes.
I'm
sorry,
sharing
I'll
now
have
the
that.
PowerPoint screen with you. Yeah?
Okay. Yeah.
Great.
See it.
Okay. Okay. So I don't know if you have seen the video, the trailer, but anyway, so we start now with the presentation. Our topic here of my research is a possibility which is not very seriously taken from until now from the science community. That is, by assigning a single property to the vacuum, we can explain many cosmological unsolved mysteries, and also explain some quantum weirdness stuff, why we can give therefore a physical explanation. So before we go to the title of the research, I will not exactly present because I'm using all this. You know me, I never present exactly the research because I assume that you have already read it, so it will be boring for you guys to replicate things that are written only in the paper. So I will present also some preliminary research for the next step, for the next paper, which concerns the same topic. So again, the discussion here concerns the possibility of there are three players in our universe, macroscopically seen. There is matter, there is light, and the third player is the vacuum. So the discussion here, the presentation concerns the third player, the vacuum, which is fundamentally different from, I say it fundamentally differs from matter, from normal matter and light. And what gives this, what is the fundamental difference my research reveals is the title here of the presentation, namely the superluminous vacuum. So before we go to the main topic, we have first to revisit something very known phenomena in nature, namely a static magnetic field or the equivalent electrostatic field. So we have to clarify here that the flux here in the magnetic field or the electrostatic field, the electric flux or the magnetic field correspondingly, the flux is not made up from photons, but quantum field theory says that these are virtual photons. So the static fields it differs from electromagnetic waves. The static fields, the flux which appears in the vacuum around the magnet or in an electrostatic apparatus, is not made up from photons, from normal photons, but these here are called virtual photons. The thing is that no one really knows what physically these are. I mean, they are described in the math, in the formalism of the theory, but we don't know what physically these virtual particles are. Namely, the type of virtual particles that consist the flux in a magnetic and an electrostatic field are called virtual photons. Of course, we have in the quantum form of the vacuum, we have also virtual pairs of electron and positrons and so on. So we could say we can have a different point of view. We don't say, instead of saying that the magnet apparatus is creating the field, we could say that the magnet is actually locally disrupting the vacuum energy. And the same also for the electrostatic apparatus. If you have an electrostatic apparatus and apply a static voltage, then the apparatus is not, we can see the other way around. The apparatus is not creating the electrostatic field, but instead is acting like a local disruptor of the vacuum energy. So if these are virtual photons, what are then the normal photons? So according to the quantum field theory, a normal photon is a point-like excitation in the quantum scalar, aka static, virtual photons field that permeates all space. So the analogy here of a photon would be if you have this web, this like a spider web of the static field, and we poke it here in one point, this will automatically generate a vibration, a circular vibration, which will propagate through all the field, the static field. So this is the photon, the analogy, the real photon, but the flux lines itself in the static fields are not normal photons, are called virtual photons. Why we say that? We say that because this is important for the next explanations we will give to this presentation. So understand now what is going on with the vacuum. I think I'm afraid we have to dive deeper into the vacuum, and namely a good starting point. It will be the famous announcement of the Higgs boson at 4th of July in 2012 from CERN, the LHC experiment, where the two detectors in the accelerator, the Atlas detector and the CMS detectors, announced simultaneously the discovery of a 4.9 sigma significance discovery of the hypothesized from the standard model Higgs boson, or else the God particle, but we will not refer to this because this is silly. Because as we will discuss later, our research shows that this is actually the imprint of the actual elementary vacuum particle. So what did these people do, the scientists and the engineers in this famous experiment? I think you already know the story, but it's a good thing to review it, and so we can continue tight up this presentation with this current research of mine. So we have two matter beams consisted from protons, and these matter beams are coming from opposite directions in the accelerator. The kinetic energy of each matter beam is about 7 tera electron volts.
Sorry, Emmanuel, are you? What slide are you on? What's it called?
It's showing two matter beams. It's called CERN LHC experiment Higgs boson detection 2012.
Put
Okay.
that
Lower left corner.
You'll see slide 1 on the main screen.
Yeah, let me see slide 1. So, if you can you hit the present or slideshow button? I think that usually works. There's a method to presenting it. You have to share your whole screen. You can't just share the PowerPoint window. I think is the best way it works, or the only way, maybe.
Okay. So I go back and
now, thank you.
You can see now, but it's not like we don't have the whole screen filled with the slide, but this works. But if you want to do,
okay,
you know,
can you see now? Can you see now this blue screen? It says above the superluminous vacuum, and
yeah, we can see that. Yeah.
Is that okay now?
You see the finger in the water next to the magnet, and but we also see your menus in Greek. So that is, but not a problem. It's just from the.
So I believe there is an hysteresis because I'm not on this screen now. I'm on the screen where it has a blue frame, like a glass, and there's a white frame. It says the superluminal vacuum, and there's a header above. It says the superluminal vacuum with yellow letters. Can you see this screen? No.
No, we had similar problems with my presentation last time.
What
when there are multiple screens involved, and the team seems to the presenting
okay, so
screen or something.
You know, I stopped sharing. I stopped sharing now.
Okay.
I go back. I go back to you. So what you're suggesting is I don't share the PowerPoint. I share the whole screen.
Yep.
Yeah, but you can move the one window to the other screen and exchange them. Then you can see. I think.
Okay. Let me try the solution Christopher suggested. So I hit present. I share screen. And okay, share screen. And then I'm presented with some options. No, just
the full screen.
Full screen, but you can
entire screen. Yeah. I've got it now. Yeah. Okay.
You must exchange the windows before you switch to full screen mode.
Oh.
No, I'm not sure about that.
Start the presentation, exchange the windows, then share the screen.
Yeah.
It's a bit unusual, but you get used to.
Here we go. Where's it gone? Oh, it's gone again. It was there for a second.
No, it's my fault. Sorry, it's my fault. Sorry, it's the first time I do this software here.
Yeah,
it's fine.
So therefore, it's easy to click the close button on the most right side.
Now, entire screen, share. Okay, and so can you now see the slideshow?
Yeah.
Okay.
Now something happened.
All right. Yeah.
Okay. Slideshow button.
Yeah.
To present.
So now this is. Can you see the first slide of the presentation?
Oh, now we are full screen presenting. Yeah. Can you move a slide for demo that we see the slide switches?
Okay. Can you see now the
perfect. Now it works. Now it works. Great.
Okay. Right. So, what part of the presentation have you missed? Have you seen the
moment? You can press the height, then the bar down. Yes. Okay. Press.
Good thinking. Good thinking. Yes. So let's say we missed every slide between the title slide and this one. Visually.
Okay. So
you
sorry, guys.
On the video, best you restart from
I make it fast. I make it fast. So okay. So I was talking about the static field of a magnet and the static field of an electrostatic apparatus. So we have here electric flux and magnetic flux. And I was just saying that the flux here is not made up from normal photons. At least that is not what quantum field theory says. But in a static field, these are called virtual photons, which should not be confused with normal photons. So, and then I went one step further and asked the question, what is then the normal photon? And I say the normal photon is, according to quantum field theory, it's a point-like excitation in the quantum scalar virtual photons field that permeates all space. So what it said is, if you imagine this is the static field of a magnet, and we poke it here, just to interrupt it here locally at a point, this will make circles that will propagate, like the lake here, the example of the lake, through all the static fields. This vibration, there will be a vibration that will propagate through this static field. So this is a normal photon, but again, the flux line itself is not made up of normal photons. It's called virtual photons. The thing is that no one really knows what these physically are. Yeah. And why I'm saying this, because this will become useful later to our discussion. It's a very important part of my presentation to understand the concept of virtual photons. So, of course, I said then that it's not the only virtual particle, the photons. We have also virtual pairs. namely electron and positron pairs, which are coming out of the vacuum, and this called all this stuff together is called as known as quantum form of the vacuum. So the other thing I said here in the first slides is that instead of saying the classical that the magnet is creating the field, the flux or in space, we can say we can see it in a different way. We can see it in a different way that the magnet is not creating the flux, but it's the disruptor. It's the disruptor. It acts like a disruptor of the vacuum energy. So it's similar to the finger here. This is the magnet, and this disrupts, it distorts the vacuum energy. So there's another point of view. We can see this, and which is very useful to the rest of the presentation. Okay, so and then I say that if we want to understand more now to what all this research is about, we have to dive deeper, even deeper, and namely to the discovery back at 2012, 11 years now. 11 years back, July the 4th, the announcement of the discovery of the Higgs boson from the LHC experiment at CERN. And then, so I continue now from here, the presentation. I say that we all know what the details of roughly the details of the experiments are, but it's very important to review this experiment, to outline the reviewed experiment, because we have to use this to explain my research. So we have in the famous experiment, we have two matter beams here that are coming from they're accelerated from opposite directions and collide to a point in space inside the Atlas chamber, which is a giant detector, and the CMS. So there were two teams that were announced at the same day, 4th of July, announced the discovery of the Higgs boson with a statistical significance of 4.9 sigma. So up to in science, it's now the normal. Discovery is announced only if it reaches about a 5 sigma level of confidence. So they were pretty sure that this was the actual Higgs boson, and I also agree with this detection. So the two matter beams had a kinetic energy about 7 tera-electrovolts, so very high energetic beams of matter, of protons, and then they collided to a point. So the collision, we should not imagine the collision like billiard balls colliding, but actually when two protons are coming very close together, the matter fields interact. So the matter fields of each proton has, of course, quarks and gluons. So the exchange during this interaction, one gluon from the one proton is exchanged, comes out from the one proton and collides from a gluon from the other proton, and this violently interaction produces a sprinkle of whatever kinds of many kinds of particles, which are described from the Feynman diagrams. But the team particularly was interested to a specific reaction, namely they were expecting to see two photons flying off in opposite direction at an angle of exactly opposite, at an angle of 180 degrees. So why is this? Why was this Higgs boson? So what happened here? What was happening here? The thing is happening, if we want to use an analogy, we can use because they were trying to discover the elementary vacuum particle. That's the whole thing. So if you imagine that the vacuum is a glass, a window, yeah, or the windshield of a car, and what happened here with this collision is we momentarily break at the point the vacuum. So it's like breaking the glass here of a windscreen of a car, and we can see here the impact, the static impact of this implosion of this impact, and this is the actual Higgs boson. So they make a static imprint of what is believed is the fundamental elementary particle called Higgs boson. And you can see here, if you break at the point the glass, we have these transverse waves, and we have also radial waves coming out. So we have transverse waves and we have longitudinal waves. So this is similar. If we imagine, if we throw a small stone on the calm surface of a lake or a pond, you get this kind of motion of the molecules of the water. We have circular motions. We have transverse waves. It's not it's a mixed wave. It's not just transverse or longitudinal like sound waves. So we have a Z part here, and we have also an X part, an X component of the motion. So this here is the Z part, the transverse waves, and as we're going deeper to the inside the water, we look the longitudinal part prevails. So it's the circular motion here is losing the Z-axis component, and it's always the X-axis component here, the horizontal part is dominating. So this is exactly what happened during this collision. We produced a static imprint of the elementary vacuum particle, which is believed to be the Higgs boson. Actually, with the Higgs boson, they were not trying to prove the Higgs boson itself. They used the Higgs boson to prove the existence of the Higgs field, which is the field which is responsible for giving the mass to the elementary particle. Yeah. But my research now shows that the Higgs boson is not the actual fundamental particle of the vacuum. If there is such a thing, if we assume that the vacuum is energy which is quantized, so I believe during this experiment, they did not discover the elementary vacuum particle. They discovered the static imprint of this particle. The particle, I believe, which is the elementary vacuum particle, is the graviton. And I will explain now myself why is this. So we have here the event, the collision. So we have the matter beams coming from the corner left up and corner right up and corner left up. And then the two photons are ejected, very energetic photons. Each has a spin 1. Yes, so this has spin -1, and this has a spin 1. And this was expected because the Higgs boson was theorized to have a spin 0. So it has to produce two opposite flying photons, gamma photons at an 180 degrees angle, because spin +1 and spin -1 makes spin 0. That's exactly what the theory says. So yeah, so because the theory says that the Higgs boson is a spin 0, it had to produce two opposite flying spin 1 photons. I mean, for normal photon is a spin 1. So the summing them up will do spin 0. But and of course the angle must be exactly 108 degrees. They must fly totally in opposite directions. So this was the unique fingerprint they were expecting to take from the experiment. They were scanning for this kind of unique fingerprint reaction. Right. But my research shows that this was not actually the Higgs boson. Is just oh yes, some detail here. why each photon is very energetic. It's 63 gigaelectron volts is each photon, because the measured value of the Higgs boson, the value mass of the Higgs boson, is expected to be 126 gigaelectron volts. I mean, Atlas has announced 126, and the CMS detector has announced something about 125.4, something like that. But let's say it's 126. So what now I believe my research shows that what they actually did here is to take only a snapshot, a static imprint of the actual vacuum particle, which I believe is the graviton. So the graviton, what they just here did, they did a static impact. So the two beams were coming very energetically. And the graviton, in my research shows, is a superluminal photon. So topologically, a graviton can be depicted as all the spin 1 particles actually can be depicted as a circle, as like a bike wheel. But imagine this now revolving very fast with a tangential speed faster than the light, the speed of light c, the speed of causality limit. And we will explain this, how a particle can spin faster than the C limit. Let me just add here that special relativity concerns the motion of matter and light inside Cartesian space, yes, and in the interaction. But the space-time itself can do whatever it wants. The space-time itself is not restricted by the C limit. Only the C limit concerns the motion of matter and light and the interaction inside space-time. But space-time itself is not limited. So a logical thinking will be, if space-time itself is not the fabric of space-time, which we say it's the vacuum, is not limited by C. So if we assume that this vacuum is also quantized, so then the quantum of this vacuum, the elementary particle of this quantum, is also not obliged to comply with the C limit. Yeah? Okay, so we have the two beams coming here, left and right, and impacting very forcefully. And then this ring here, the graviton, which is Planck sized. Okay, we know that standard model says that all the elementary particles are dimensionless. But, yes, this is very convenient mathematically. But there is still ongoing research from big labs that are still looking for a finite size of elementary particles. So yes, it's a mathematical description, and it's very convenient to say that all the elementary particles are dimensionless. However, nature, we don't observe this in nature. Things in nature always have some size and some shape. So, so imagine this graviton be a rotation of energy, a wheel here, a circle which is rotating superluminally, and the two beams hitting make it for a moment violently stop. So it's losing its angular frequency, its angular vibration, and this single moment of time, this instant, which can be 10 minus 20 over 10 seconds in the scale of attoseconds, yeah? This just still moment produced the Higgs boson. So it is actually an artifact of the experiment. It's not the real behind the Higgs boson. The real particle, we believe, is the graviton, the real elementary particle of the vacuum. The Higgs boson was just an artifact of the experiment. It's real, of course, but it's just a scalar, because the Higgs boson is the only scalar static elementary particle in the standard model. And this is actually ties very nice with what we are saying here. They just make for a moment the static, they stop the graviton for a moment, which was rotating here vibrating superluminal, and they produce a static imprint for a moment of this of the graviton, which is the Higgs boson. But the real particle behind this is the, according to my research always, is the graviton, which we say it's a superluminal particle. So, okay, and some I want here to stress something. We're not talking here in my research. We're not talking about tachyons, because my research says that the vacuum is a condensate of gravitons. So it's not like particles that are translating with linear speed and going up the way in a trajectory linear. We are talking here now about vibrations, about vibrational energy. So imagine a lattice of all these gravitons, like a material, and they rotating faster than the speed of light. They're rotating at faster of the speed of light in place. They're not moving linearly through the space, but just so a better description is always to be that it's a condensate of gravitons. Yeah. So we are not restricted here about the tachyon limitations that say that, you know, a tachyon can, if it's superluminal, it cannot decelerate to luminal speed. It has to remain because it has negative energy. But we're not talking now here about tachyons. Okay, we're talking about superluminal vibrational energy, harmonic oscillation of particles. Right. So again, here we have the two matter beams. We have the violent explosion. It produces a collision point here, a static imprint of the graviton, which we call Higgs boson. But the actual vacuum particle is the graviton, which is a vibration. You can imagine it like topologically, it's equivalent to a circle which rotates with angular frequency with a tangential velocity higher than the c limit. All right, but what then happened? The graviton got decelerated by the impact of the two matter beams, got momentarily decelerated to luminal speed, and immediately it took off from its superluminal spacetime and came to our spacetime. So by doing this, by taking the graviton out of its superluminal energy state and transferring it to our, so it's a phase transition actually, transferring it to our spacetime, Einsteinian spacetime, it immediately produced ejected these two photons. So the implosion energy, the impact energy is converted then, the impact energy which generated the Higgs boson is converted, is decayed automatically to two gamma photons, right? Yeah, but there's now a problem. Why a single graviton came out and decayed to two photons? Why not just decay? It should decay in one photon. Not, I mean, it could be decaying in two photons, but why not also in one photon? Why it decayed in exactly two photons? So here we come now to a real existing phenomenon, which is known, and you can use the citations in my paper for reading about this phenomenon. It's a superluminal phenomenon, and it's called relativistic image doubling effect, or in short, RID. So when this phenomenon is happening? So we have here a medium which has a refraction index of 1, so it's a vacuum actually, and the photon enters a material which has a refraction index larger of 1, so it's slowing down light. So, but if the photon, the initial photon has a very high momentum, like a cosmic ray, for example, because you remember the momentum is photons don't have mass, but it can carry momentum. So the momentum from the Broglie equation is p equals h Planck divided by the wavelength. So if it's very high frequency, it will carry a lot of momentum. So if it enters with a very high momentum, it does not directly go from c speed to the lower speed. So for a few picoseconds, or maybe nanoseconds, smaller than picoseconds, for a small fraction of time, it will actually decelerate. So it will not immediately phase to the lower speed, which was dictated from the refraction index of the material, but it will have a time period of gradually decelerating from luminal speed to the subluminal of this material. Yeah. But then, if we could, an observer, what will we observe at that very short period? What will the observer will observe? If we could assume, if we could see a single photon, the observer will see this very strange effect. From a point in space, he will see a photon flying towards the initial direction here, and simultaneously a photon going to the opposite direction. So we believe that what was actually detected in the famous Higgs experiment, in the famous Higgs detection experiment, was an superluminal relativistic image doubling effect. But I have to say here,
I see it as a pair production. The photon is its own antiparticle, and so it's no problem to produce two photons because one is going to future and the other in the past. And
okay. Yeah. That's actually the explanation. That's why Goethe had also the space-time light cones. But my explanation is not so much oriented in special relativity, but as an actual effect of superluminality. Yeah, we explained that now from a different way. So thank you. Shall I continue? Yes? Okay. So you can ask later on, yeah? Thank you. So that we believe, why we say that, because if this effect is very important, that if this effect is actually taking place, this is inferring then very strongly that the vacuum energy is superluminal energy. So if this effect, because I have to say here, this here is not an apparent effect. No. In our space-time, it's very real. There are actually one graviton is coming out from the superluminal space-time and it's coming into our space-time, but it produces actually, due to this effect, the relativistic image doubling effect, it produces a pair of photons, yes? Okay. But again, these two photons, I'm not saying that this is it's not it is an apparent effect. It's not an apparent effect. In our space-time, it's very real. These two photons are very real energy. Yeah. Okay. But if it's this effect, it proves that it's some kind of proof that the vacuum energy is actually superluminal. That's the point of making this argument. So you can to get a better picture of this relativistic image doubling effect, which is a superluminal effect. We can see that in sprites. You know this. I'm not saying necessarily that the sprites phenomenon is due to this relativistic superluminal image doubling effect. But I just use this just for a visualization, so you can have a better picture what we're talking about. Yeah. So sprites are these thunderbolts in the upper atmosphere. This phenomenon is not yet fully explained. Even today, it's not fully explained. And you have from a point here, you get these two cones of light of thunder, which is more shaped like a cone, more cone-like. You get from a single point simultaneously lighting coming down and up. So this is actually an actual photo taken from a high altitude aircraft. So this is a good visualization of this relativistic image doubling effect we're talking about. We believe it was the detection of the Higgs boson. It was actually the relativistic image doubling effect caused from a source graviton coming out, losing its kinetic superluminal energy, coming out to our space-time, becoming luminal, and therefore was producing this relativistic image doubling effect, and the two gamma photons decay. So this here is just an visualization, an analogy of what it would look like. So there's also another. So if we say that this the graviton is the elementary vacuum particle, there's another kind of evidence or analysis, whatever you like, that theory says that the standard model says that if there is a graviton, it must have spin 2. However, with our analysis, we show here that in order this is only relativistically impossible to have spin 2 unless the particle is superluminal. Namely, it's equivalent to a superluminal spin 1 photon. So how we came to this conclusion? In my previous research, using a topological fiber model for depicting the spinor of an electron, the half spinor of an electron, we showed that if we use this data here, if we use length of so we have here, I don't know, I will play the animation, but I'm not sure if it will show up in this presentation. You remember the animation of the electron spinor. Yeah. I switch now to the, can you see the animation? Hello?
Yes. Yeah, we can see it.
So the animation, the electron, we use this fiber model to topologically represent the spinor behavior, the 4 pi symmetry of an electron. So each point here returns to the initial place, to initial phase, after 4 pi rotations, equatorial rotation. You see here the spinor of the electron has a z component, a revolution, in superposition with the equatorial spin. So you have a revolution because it slides down, you remember? It's going down, it's sliding down, and in the same time, in superposition, the whole manifold is also rotating the xy plane. So if you now use this kind of topological analysis or spinor analysis, and by the simulation, if we use a trajectory, a longitude, a latitude component, the z component of the length of the z revolution is LR, and the length of the equatorial revolution is LS. And if you use the ratio of 0.866, actually it's the exact number is square root of 3 divided by 2, but let's say approximate this number here. And if you match this with tangential velocity, spin velocity, and revolution velocity of the same ratio, then you get a Lorentz factor of 2, a time dilation of 2, which this actually was the explanation of why this is happening. So because the time dilation, the 2 pi symmetry, the actual in the frame of reference of the electron, we say that the symmetry is actually 2 pi. But because the time dilation, the relativistic effect, the time dilation times 2, this is converted in the lab frame as 4 pi. So in the neutron interferometry experiment, the self-interference of because this is the experiment used for measuring the 4 pi symmetry of the electron, because this time dilation effect, the actual symmetry of the electron, which is normal 2 pi symmetry, is translated in the lab frame at 4 pi. So that's okay. That's fine. The problem here is with the spin 2 graviton, because if you do the same analysis, and the graviton now spin 1 has 2 components, has a z component of revolution and an xy component, but the graviton is a spin 1. It's a superluminal spin 1 photon, and spin 1 means that it's a circle. Topologically, it's a rotating circle. So this is the shape actually of the manifold of the graviton and the normal photon. The only difference is spin 2 is a superluminal photon, so that now the tangential velocity is faster than c, and we do the same analysis because the spin 2 particle is expected to have a 4 pi symmetry. So the half spin has a 4 pi symmetry. Correspondingly, the spin 2 particle is expected to have a pi symmetry. This is not my saying; it's written in the literature. Okay, so but if you do the same analysis, so what means the pi symmetry? It means that it makes a 2 pi rotation by transversing only the half circle, pi. It's making a 2 pi rotation at pi. So this is a relativistic possibility. At least at a special relativity, it's impossible, unless the particle is superluminal, because superluminality actually allows this kind of behavior. So we see here. We have the spin-off for the electron. It's time dilated ×2. But if you do the same analysis, this actually results to a ×2 time contraction, which is impossible in special relativity. It's prohibited. The Lorentz factor comes out half. It's smaller than 1, which is prohibited by special relativity. So spin 2, using here my model, spin 2 is an impossibility in special relativity. It should not exist, a particle spin 2 in special relativity, unless again I say it has an intrinsic superluminal property. So this is also some analysis we can use for evidence that if the graviton is the elementary particle of the vacuum, it must be superluminal, which again I say I believe it does not violate special relativity, because I remind you, special relativity talks about matter and light moving inside space-time, but it does not limit space-time itself. So now we're talking about the quantum, the possible quantum of the space-time. So it's not obliged to follow the speed limit, you know? Okay, so a spin 2 particle, as we said before, is topologically equivalent to a spin 1 particle, a normal photon, but which is revolving with an angular velocity faster than the light, FTL c speed. That's the difference between a spin 2 and a spin 1 particle, according to our research. And of course, it's bosonic in nature. It's a boson. So some predictions now. The graviton spin 2 particle is the quantum vacuum elementary particle and has an intrinsic superluminal V greater than C oscillation frequency, harmonic oscillation. The graviton is phase I mean, now talking about the experiment, the LHC experiment of the detection of the Higgs boson. The graviton is phase transitioning into a spin 0 Higgs boson of minimum energy about 126 giga-electron volt, which following can decay into 2 opposite trajectory gamma photons. Okay? And the other prediction is of my current research, my preliminary research, is that the CERN sensed detection of Higgs boson at 2012 by the 2 gamma photons decade observed was possible a superluminal relativistic image doubling effect, RID, caused by a decelerated source graviton. So the graviton was, due to the impact of the two matter beams, was for a moment decelerated, lost his angular frequency, made the Higgs boson imprint, which is a static imprint. It's that's why it's the standard model says that the Higgs boson is the only scalar particle in the table of the elemental particles, which is actually also supported by my research here. So the static imprint for a moment, the decelerated imprint of the graviton was the Higgs boson. But the actual behind the scene, I believe, quantum vacuum particle is the graviton, which is, however, a superluminal particle. Okay, so how a proposal, how can now detect this superluminal nature of the quantum vacuum we predict? So it's predicted in my theory that the two initial gamma photons initially to be superluminal. So they are non-Lorentz invariant, which means they were actually virtual photons. Remember the first two slides discussion we did about virtual photons? So we say that the decay of the two gamma of the Higgs boson to the, I mean, it just went first is the graviton, it phase transition to a Higgs boson, and then the Higgs boson decay to two gamma photons, which is due a relativistic image doubling effect. But these photons had a superluminal speed. Therefore, they were actually virtual photons. Okay, so how we can use this now in our advantage to experimentally verify the superluminal vacuum? Therefore, the verification is possible by very precise attoseconds accuracy or less, measuring the propagation delays of the two gamma photon Higgs boson decay to the LHC detector, Atlas, for example, sensors. So the time they will take from the impact point here to travel to the sensors, which I believe were calorimeters. I mean, they were measuring the heat signature of the two photons. So, and if this the time will vary to the slightest, because the difference will be very small from the predicted value, then this can be used as an evidence of superluminal energy. Yeah. But of course, maybe this experiment is now restricted from technology. Maybe we cannot attempt this kind of accuracy we needed, but we can compensate for that. We can make the detector here of a larger radius. So we can make this radius larger to give us enough space so we can measure the time. Okay. So now we will continue to the. Don't be afraid, my presentation has 25 slides, so it's not a very big presentation. So, but if you want to take a break, yeah, no problem.
I'm okay.
Okay.
On my side.
Yeah, thank you. So now we're going to discuss some more practical questions. Why the superluminal vacuum? If we assume that the vacuum is superluminal, an unknown type of superluminal energy, why it appears to us as nothing? Excuse me, I have to drink some water. So yeah, it's not just a philosophical question, but it has also some very important implications. So we will discuss this in the next slides. Also, which is also related about this nothingness of the vacuum. The other thing we will discuss following is its possible connection with dark energy, aka the cosmological constant problem, because dark energy is very related to this unsolved physics problem today, the cosmological constant problem. And of course, also about the connection of the vacuum energy with the dark matter. Also, its connection with quantum gravity. I mean, we already talked about this, about the graviton. And the connection with of the superluminal vacuum with virtual particles. And lastly, the connection of what superluminal quantum has to do with the overall weird behavior of quantum mechanics. So let's make a naive analysis. I mean, it looks naive, but because the topic is quite difficult, let's forget about for a moment physics and just make let's see what just mathematics has to say about that. What if something is superluminal? What special relativity maths are concluding? So the assumption here is that the free space, the ideal 0-point vacuum, 0-point energy, but it's not actually zero. It's a non-zero value, but it's very small. It's called 0-point vacuum. So it's the ideal vacuum. And we say that the assumption is that this energy is a superluminal state of energy where there are not yet elementary quanta of the vacuum, possibly theorized graviton at the Planck scale, harmonic oscillate. Also, this hypothesized quanta of this vacuum, of this energy, harmonic oscillate in place. That's very important. They're not tachyons at speed v times c, larger than c. Okay, not to be confused with translational motion of tachyons. So if we do the just the Lorentz transformation for v greater than c, that is literally the conclusion of the Lorentz factor gamma calculation. That it produces the reciprocal of the Lorentz factor becomes a pure imaginary number. So therefore, the Lorentz factor being a pure imaginary number and not a real number, that's the vacuum appearing as nothing. Yeah. So if you literally translate the mass, that's actually what the Lorentz transformation is saying to you, that it's a virtual particle. It has a pure imaginary Lorentz factor, so it's not a real number. Therefore, it will appear to our space-time as nothing. So, yeah. But we also had this kind of analysis we can use as a further to support our argument. Relativistic topological analysis of the theorized spin 2 of graviton, which is theorized to be the elementary particle of the vacuum, shown it is only possible if this is having an intrinsic superluminal vibration, thus a pure imaginary Lorentz factor gamma that would render it as nothing in our normal spacetime. Also, in compliance with special and general relativity, normal matter and light interaction and motion are bound to the speed of causality, limit c, speed of light in the vacuum. However, space-time itself is not bound to c. Therefore, it is a logical thought that in the vacuum, if the vacuum is quantized, its quanta could also not obey the c speed limit. Yeah. All right. So, continuing now. So this, what we're talking about is that the gravitons, this gravitons condensate, resides to a totally different space-time than ours, but it's actually in superposition with our space-time. So the two space-times are entangled. Yeah. The superluminal space-time where the gravitons reside, the gravitons condensate, is out of phase from our matter-like, time-like Einsteinian space-time. So it resides in superposition with our space-time in a different space-like discrete space-time. Okay. Also, another way to see what the graviton is. A Planck scale or sub-Planck, thus superluminal vibration harmonic oscillation frequency, would re-enter the hypothesized quantum vacuum quanta, aka graviton, to a quantum black hole. So if you have a vibrational frequency and harmonic oscillation that exceeds the Planck frequency, then you will have then you will create a singularity, actually a black hole, a quantum black hole, a macroscopic quantum black hole. But this then ties very nicely with what we observe of macroscopically of the vacuum, because it explains the nothingness property of the vacuum created by the singularity of the black hole. So here we have the graviton, okay, and here is the singularity. If you imagine it, that this is now a microscopic quantum black hole, you have the singularity after the event horizon, okay? And with the photon ring here, this is the 0-point energy. The photon ring here explains the 0 point. So we have the gravity is created by the singularity, the nothingness we see of the vacuum is created by the singularity here of the graviton. And the 0-point energy we actually observe is this, this area here of the photon ring of a black hole. Yeah. So this this explanation explains very nicely, I believe, both phenomena, the nothingness of the vacuum, and also the actual observable 0-point energy of the vacuum in the form of noise. Okay. So we will now discuss the superluminal quantum vacuum connection with dark energy, aka the cosmological constant problem, dark matter, and quantum gravity. So, by assuming that the vacuum is superluminal energy and its fundamental particle is the superluminal graviton, this actually solves the cosmological problem, namely, the cosmological constant problem is or discrepancy is called also the worst prediction in physics, because you have the quantum electrodynamics theory that predicts that the vacuum energy density is 120 orders larger than the actually observed by cosmological expansion of the universe. So the expansion of the universe actually predicts, observes a much smaller, much smaller, 120 orders smaller vacuum energy density than the one predicted from theoretically by QAD, quantum. And this is the worst prediction in physics, and one of the unsolved, great unsolved problems in physics. But now, if we assign this simple superluminal property to the vacuum and say that it's actually a superluminal type of energy, then most of the energy, the missing energy, I mean the missing energy between the predicted from the QAD theory and the actually observed, because the expansion, the accelerated expansion of the universe, the missing energy is actually the dark energy. And it's hidden energy. Why is hidden? Because the superluminal property we discussed before. If something vibrates at superluminal speed, it becomes totally undetectable and invisible to our space-time. So now the missing energy between the QAD, this 120 orders missing energy, is the dark energy, but because it's superluminal, according to our theory, it's hidden energy. And we observe only its Lorentz invariant noise, the part of the noise that complies with the c-speed limit, that's the Lorentz invariant. That's the 0-point energy. Okay? So we see only the tip of the iceberg. Because the energy is superluminal, the dark energy, we can see only the tip of the iceberg, which is the part which is Lorentz invariant, which obeys to the speed limit, and this is actually the 0-point energy we observe. So the big difference, the big gap between the 0-point energy we actually observe and the QED energy predicted is because the superluminal property, intrinsic property, we say the vacuum has. Okay. Next, the superluminal spin 2 omnipresent graviton is the elementary quantum vacuum particle and as well as the elementary quantum of gravity. So now we're talking about quantum gravity. The graviton creates both the dark energy repulsive effect, similar to radiation pressure, responsible for the expansion of the universe, and also macroscopically then, gravity can be explained as a gradient of the number density of gravitons in normal matter and cosmological black holes that presumably in this is in higher concentration than the rest of the surrounding 0-point energy vacuum. So you have, whenever you have matter, you have a larger concentration, or cosmological, big black holes, normal black holes, you know, you have a larger concentration of the gravitons related to the rest of the surrounding vacuum. So this creates a negative pressure, which is equivalent to gravity. So it's now gravity can be explained as a negative, as a gradient of this condensate, of this quantum vacuum condensate. What is the connection of possibly the connection of the quantum vacuum of the superluminal quantum vacuum with dark matter? Now, dark matter could be explained as a side effect of the gravitons that concentrate more on the boundary of matter objects in its aka surface. As a halo, increasing the gravity field of normal matter to a slight %, which has, however, a significant observable effect at galactic scales. So the gravitons tend to, I mean, it's not just the galaxies. The gravitons are surrounding even also the atoms or all the elementary particles. They're all around as virtual particles, yeah? The gravitons. So, and actually, in the last 2 years, we have the muon experiment, the famous muon experiment, in Fermilab, the anomalous magnetic moment of the muon. And currently the results which came out from the experiment are at 4.2 sigma significance. If they're becoming closer to 5, then this is a detection. And what is detected, what actually is, will be verified, that the virtual particles actually exist, because the theory they are saying is that the people there in the Fermilab is that a soup of these virtual particles is surrounding the muon and changing slightly its magnetic moment. So this will be also a confirmation that the virtual particles are actually not just imagined; they have an actual effect in our space-time. Yeah. So dark matter can be something like that. Side effect of the gravitons superluminal condensate that concentrate more to the surface of around the object and add therefore gravity. So I believe this picture sums up everything until now and ties everything up. So we have here the graviton. The singularity beyond the event horizon, if we see it as a quantum black hole, is creating the gravity effect. The ring here, the photon ring of this very energetic ring, is actually the dark energy. Okay, and we cannot observe this, we cannot measure this because the superluminal spin, the revolution here, the very energetic here, and the photon ring here. Because the superluminal speed, we cannot directly observe or measure this energy. So this energy here is hidden. This is the dark energy, this ring here, this very bright energetic ring. And the halo here, we see we have a cloud here, a halo, a noise. This is actually the 0-point energy, which is actually detectable. So we have the inner part here is the gravity. It's creating the gravity. The graviton here is creating gravity. The photon ring, the energetic ring here is the dark energy of the graviton. And the cloud here, the halo of the graviton, is the detectable 0-point energy, dark energy, or it's called quantum form of virtual particles. So I think that then we're coming now to the end. Another 3 slides. So it's very important now to understand also how these virtual photons, how the superluminal vacuum manifests in our space-time. And besides gravity, another manifestation very known of gravitons and the quantum superluminal quantum energy is electromagnetism. So if you have, you remember the first 2 slides of the magnetic and electric flux. If you have here, this here represents a flux line. Could be electric or could be magnetic, doesn't matter. Actually, it's made of from the same stuff, the flux line. It's made out from gravitons. And the difference between an electric flux line and a magnetic flux line is only the divergence of the curl. Yeah, magnetic flux lines have, according to Maxwell, divergence of 0. Yes, and electric flux lines have a non-zero divergence. That's the only difference. But both flux, electric or magnetic, are made up of, according to our theory, to my theory, from gravitons, and namely from coherent alignment of gravitons forming the flux line. So if we zoom in here now, this very small region, these are actually coherently aligned gravitons, and the noise of the gravitons here, we see the noise, the 0-point energy of the gravitons, is creating the actually flux line. I mean, this is the Lorentz invariant part, which obeys the C-split limit. The dark energy is non-Lorentz invariant, so it's superluminal. Okay, and this the center is the gravity, the singularity, which is nothing, which creates also the gravity. The absence is the gravity of anything. Yeah. So if the gravitons coherently aligned here, they form the flux line, which again I remind you, electromagnetic flux is the basis of all electromagnetic phenomena, from static fields to dynamic electromagnetic waves. So it's very important. It's very fundamental. So that's why, if you remember in the presentation of the fiber model of the electron, I said something weird. I said something that maybe is controversial, that for me, according to me, electromagnetic flux is even more important than the element than elementary particles like the electron or the positron or the photon itself, because I believe it's the material by which the energy by which all the elementary particles are woven. Yes, except the graviton, because the graviton is creating the flux itself. Yeah. So the graviton is you can say it's the most fundamental particle there is, the graviton. Yeah. So yes, whenever these gravitons align coherently, we have a flux line. This is actually nothing new. If you read Maxwell, and I can point you to the reference of his work, Maxwell imagined that each point in a flux line is formed by microscopic vortices, quantum vortices, which are all these vortices are aligned in space, and the magnetic flux line is passing through the center of all these aligned vortices. So that was actually a view of Maxwell. Okay, so this, I believe, is the last slide. The superluminous vacuum. Yes, we now will explore the relation of the superluminal quantum vacuum we theorize, with quantum mechanics. Yeah. So Again, as I've said in the beginning of this presentation, by assigning this single intrinsic superluminal property to the vacuum, which fundamentally is different from our normal matter and light, although the source of an origin of all 4 known fundamental forces. That's why what I believe in nature, through a phase transition mechanism. You know, I refer here to the deceleration of the graviton coming out from its space-time and coming to our space-time. We can explain the apparent weirdness of quantum mechanics, like quantum entanglement and non-locality, quantum tunneling, quantum superposition. You know, this white, the particles is in all the places at the same time, superposition. And in general, also explain quantum indeterministic nature, or the indeterministic nature, or in general, of quantum mechanics. This is also supported by 2 research papers, independent research papers. You can find here under these citation numbers. The authors are Dragan and Eckert. Eckert also is one of the famous fathers of quantum cryptography. These papers were published at 2020 and 2021. They have many downloads, over 100,000 downloads. If you go to the paper, to the actual homepage of the article, the journal, you will see the downloads are over 80,000 downloads. So, but the only difference is Eckert does not mix, Dragan and Eckert does not mix the vacuum. This is my novel idea. Eckert and Dragan says if we extend the special relativity to include also superluminosity, then all the quantum weirdness of the quantum world can be explained. And you can access these papers under these reference numbers in my current published paper. So the home message, the home message of this presentation, I want you to take with is that the benefits are too big to be ignored and grandfather research. We must break off from the speed of light limit. Yeah. So you see, as we have said in the beginning, by assigning a single property to the vacuum, thus being superluminal unknown type of superluminal energy, which is I believe the fundamental difference that differentiates the vacuum from normal matter and light, then we get suddenly answers to many unsolved problems concerning cosmological unsolved mysteries, but also quantum mechanical problems. So the benefits are too big, superluminal research to be further ignored. Yeah, and so yes, this. But please no, don't go home yet. I'm not finished. Don't go home. There are two more slides. It's bonus material. It's yes. So please, we have a small bonus here. So we're going now to the realm of science fiction, more science. It's more speculation, but why not? It's fun. I mean, history has taught us that science fiction comes first, and then comes to science to that makes it real. So yeah, I want to talk 2 more slides, please, about FTL travel, faster than light travel. So I mean, if it's possible, according now to this research which I presented, to have positive mass traveling faster than the speed of light in a vacuum. Yeah. So according to Maxwell, if you see this equation here, Maxwell also inferred by this research presentation, the speed of light, c, is exclusively dictated by the free space vacuum. Yeah. So if you see the equation here for the light speed, it's dependent by two parameters: electric permittivity E0 and magnetic permeability mu0 of free space. By these two parameters of free space, the vacuum. Yeah. So therefore, the speed of C could be seen as a measure of the resistance of the medium, the vacuum, to linear motion of mass, the cause of inertia, similar to friction. So imagine that the vacuum is some kind of medium which prohibits the motion of positive mass. Yeah. So that it creates the inertia actually. So in gravity, because inertia and gravity is actually both sides for the same coin. Yeah. They have the same cause, which we believe is the vacuum energy, the gravitons. Yeah. So the solution for FTL spacecraft, from the FTL faster than light spacecraft, is obvious. Get rid of the vacuum around the spacecraft. So, okay. So, what we're talking here? So we could create a finite thickness shell around the spacecraft, a true void, but more practical because true void is very difficult. So if you want to get rid of the vacuum, you create a shell. I don't know how this can be created. It's a technological problem, but under what physics it can be created. Although I can imagine what the physics could be, an outline of this physics. We can discuss this later if you want in a different meeting. So you create a shell of finite thickness of true void, but true void may be impossible. So you just practically lower the 0-point energy of the surrounding vacuum to a lower level. So you make the vacuum be lower in density from the nominal in the free space. Yeah. And that will allow the spacecraft and its occupants to slide through Cartesian space with FTL speeds. So if you get rid of the vacuum, which is hindering you from getting to FTL speed, you can then slide like an air bubble, sliding almost frictionless through a more molecular dense liquid. Yes, so yes, Star Wars, prepare to jump to hyperspace. Why not? So, and how this will work, just a few more words about this. The problem is that if you isolate this bubble here, okay, this bubble has not been to, the shell here has not been to be very thick. It could be just centimeters thick or millimeter. As long as it exists, that's the important thing. And I have to also to stress out here that the occupants of inside the bubble, there exists normal vacuum, because matter and light cannot exist without the vacuum. So the people here will be protected. They have normal environment. And also they will be protected by inertia, because your bubble is now isolated from the surrounding inertia of space, and you will not killed by inertia. Yeah. So if you remember the inertia dampening field in Star Trek, not the Star Wars, they said something about inertia dampening field yeah. So, but there's a slight problem. What you do, you set your coordinates. It's exactly like Star Trek. So you want to go to place A to place B. Okay. So you set in your computer your coordinates, you calculate the trajectory and all that. Then you use normal propellant. Normal propellant drive could be some gas chemical drive or ion drive or even a nuclear drive. You accelerate, you gain momentum for a few seconds, maybe a minute of normal travel. Then you switch off the propellant drive and you turn on the FTL drive. And because the initial momentum and you have now displaced the vacuum, then you will you go to FTL speed. Yeah. The problem now is how you decelerate. Because if you're already in the bubble here, in the FTL, the vacuum displacement bubble, which it's literally the phrase from the Star Wars, prepare to jump to hyperspace. And what is hyperspace? Hyperspace is actually this bubble here, this bubble of lower 0-point vacuum energy, yeah? So the problem now is how you decelerate, because now you're isolated from the inertia, from the surrounding space. You cannot use the third law of the Newton to use the chemical propellants to decelerate. You don't have, you are isolated from the inertia from the rest of the space. So you cannot use Newton to decelerate. So how you decelerate? That's the problem. So an idea is you just make here the displacement field, the vacuum displacement field here in front of the spaceship thinner. You make it weaker, but you make it very gradually, because if you make it very up, if you are at FTL flight and you suddenly switch off the FTL drive, you will be torn in pieces because the sudden regain in inertia. Yeah. But if you do now, you control the field here in front of you, make it thinner, then you can gradually go to a non-relativistic speed, or even come to full stop, and then you switch off your FTL drive. I think that's the way. Of course, this is speculative now. I'm not doing any quantitative analysis, just a qualitative analysis. I did not calculate how much energy you must have to get this displacement field, this vacuum displacement field. But yes, it's fun. Why not? And the other thing is, even if your spacecraft is at full stop and you turn on your FTL drive, then you become totally invisible. Yeah, because there's a separation. There's no void here. There's no vacuum, and the photons cannot propagate without the vacuum. Again, my conclusion is that matter and light cannot exist without the vacuum. So yes, that was, guys. Sorry for, I believe that I did not bore you to death. And yeah, maybe even for your own, you can get a couple of days which are useful to your own research. So thank you very much for watching my presentation, and I'm open to any questions you may have. Thank you very much.
Oh, great. Manuel, great.
Thank you.
One question I have is about the why we cannot see in
sorry,
nothing,
I have to, Rajan, sorry, I have to go
Can
out
you hear me?
from the, yeah, stop sharing, yeah.
Okay.
Oh, yeah.
Stop sharing.
So, yeah, one question I have is, you said why you cannot see the superluminal thing. Is there another possibility that if something is going faster than speed of light, right? So there is no way, the way we see it is the light goes there and comes back to us. But in superluminal thing, it goes so fast, the light cannot come back. So it will appear as dark. Is that possible?
Yes.
Also, another explanation.
Yes. Yeah, there's a very good explanation if you want, if you find the citation of Namirov. It's in the side of the presentation. I think it's 35, the citation number 35 and 36, if I'm correct. It's Namirov. There he's doing also a very good analysis of the relativistic image doubling effect, which, by the way, every pair coming out of the quantum form of could be a relativistic superluminal image doubling effect. There's a very good question: why always out from the quantum vacuum always the particles come in pairs? Why there's pair product? Why not just one? So the superluminal relativistic image doubling effect is very good explanation for that.
Yeah, I think you explained nicely, Emmanuel. It was excellent presentation. So I would think that that oscillation is quite possible, because even in the vibration atoms, they vibrate all the time. So the superluminal, the harmonic oscillation, will automatically, so something goes down, it goes up again because of the potential energy and kinetic energy transfers, it'll keep oscillating and it'll appear as two of them. I think it makes sense.
Yes, my problem is I didn't want to go to the tachyons realm because there are many problems with reversal of the arrow of time and all this stuff. But again, all this can go besides because I've said that my research concerns the space-time itself, the fabric. So it's not restricted by the c speed limit. The causality refers to more to translational motion of things inside space-time, not to vibration. So if the space-time is not constricted itself, the space-time itself is not constricted by c limits of the speed of causality, and it can do whatever it wants. It's not actually this, not my opinion. It's inside special relativity. Yeah. So then the logical thought is that the quantum of the vacuum is not obliged also to do to obey the same speed limit, and it's natural. Now we're talking about Planck size particles, even sub-Planck. So why it should vibrate at the speed, not faster?
I have one more question.
Please,
yes.
I'm not speaking so good English. I have three questions. I have three questions. The first is you made example with a spin 2 and a spin a half. The spin 2 was prohibited because
yes, because it produced the pi symmetry it's producing.
What would be if the gamma of that particle would be 1 and not a half, because the graviton is the reason for existing relativity effects like time dilation and so on. And you can say the graviton does not have to obey then relativity because it's the reason for it. And if you say graviton may exceed light speed, then you can say graviton does not obey time duration.
Yes.
What would be with your example?
Yes. Okay. If I understood correctly, thank you, Gary, about the question. So a spin 1 particle, like a photon, a normal photon, has a 2 pi symmetry. That's fine. It's just a circle and makes a 2 pi rotation. Yeah. Mm-hmm. The half spin of electron and all fermions actually.
The electron is not the problem. I understood.
It's 4 pi. It's 4 pi. Yeah. Mm-hmm. The spin 2 now, the spin 2 particle, it said it's not mine. It has a pi symmetry, so it makes a 2 pi rotation transversing only the half circle. So it makes a 2 pi rotation at pi radians. Yeah. So if you do now the Lorentz transformation, this is a natural Lorentz factor of half, which is not allowed because Lorentz factor must be always larger than 1. So this actually
what would be if this
but this is time contraction. Time contraction. And time contraction, the lab frame is not allowed in special relativity, but it's allowed in superluminality.
Yeah, but if your particle or graviton has not if the factor is not a half, but it is 1 because relativity does not apply because the graviton itself is the reason for relativity, but not for itself. It does not have to obey its own laws.
Okay, yeah, that's a good interpretation. Yeah, I know.
I only want
that's fine.
to ask you if you may explain it in this presentation later on this case. You might not have to explain it. Please put it.
Say that in German. Understand? Say that in German.
Ja, also ich wollte nur wissen, also dass du das in die Präsentation aufnimmst für diesen Fall, also berücksichtigen als dritte Möglichkeit. Das würde mich interessieren. Ja.
Your analysis, deine analysis.
Mm-hmm. And then my second question is what kind of was heißt Treibstoff, fuel, your FTL drive should use, because if you want to accelerate to speed greater than light speed, the drive must or the fuel must propel with a speed greater than C2. Yes. What do you want to know?
What I'm saying. Okay, the FTL drive was just for fun, yeah. But yes.
The drive must be faster than light speed 2. Yes, I want to say. And my third.
No, because no, because what? So you have to drink some water, please. As shown by Maxwell, by the equation of the C speed limit, and also my research shows, is that the C speed, the speed of causality, is exclusively dictated by the vacuum.
Mm-hmm.
So you don't need to have the chemical propellant has not to produce any faster than light. You just displace the vacuum. You get rid of the vacuum, and then you use the initial momentum of the chemical propellant of your spacecraft. And when you get rid of the vacuum, then immediately you get rid of the speed of causality. You don't have more any limit. You can use your initial momentum to slide through the Cartesian
but the momentum must have a certain velocity, and the velocity, I don't know. Your picture was on your picture there was the field around, and the ray from the drive got outside this must it be inside, remain inside, or must it direct outside?
Yes, the vacuum inside is normal, but there is a thin layer, a thickness, where the vacuum is lower than the surrounding vacuum. It's similar to air bubble going through a liquid, which is almost frictionless now, and can slide through. I don't know if. But I mean, this is just speculating. This was speculative.
When you allow, I would like to add something to this, because first of all, we don't want to go to the patent office and really have a working one.
We are a long way.
But I can show you an analog, which I can quite see what you are after. You may confirm or disfirm that what I'm saying is. Have you heard about the Squall torpedo from the Russians? So they were
Yes.
able to have extreme speeds.
Yes.
If I'm right,
Supersonic.
4,000 kilometers per hour below water, and they do that with a rocket.
You mean you're talking about the submarine, the torpedo?
Yeah, the submarine. Yeah, so the submarine
yeah.
has the density of the water and have to press the water aside and
Mhm.
cannot really
Exactly,
go faster than 60 miles per hour or something like that.
They're
And
using
if
an air layer. They're coating the torpedo with an air bubble.
Yeah, and they
use
coating
this,
the air pressure around the torpedo, and the torpedo is
Exactly.
way
That's a very good
100 times
example
faster than the submarine.
Yeah, I heard of it.
It's like you fly underwater, and this is a similar effect which I would take into consideration than what your
I thought they used some sort of superheated gas, Christian. I think I recall that from the 90s or something, and they'd fill the bubble with like this gas to like push the water out as well. That might have helped. But I was thinking
the propellant must have the same speed like the submarine.
Well, I'm thinking, Gerd, that like if you think of a spaceship that's traveling through space, and we normally think of the vacuum as having no resistance in a normal sense. So quite aside from what Manuel's talking about, but if you have like just a normal space drive and you've a clear run at it, you could build speed and build speed definitely up to c as the speed of light. But if you're removing this the vacuum energy, which is causing the speed of light limited in the first place, and you just have your normal engines, then theoretically you should be able to build beyond c. And I think that's what Emmanuel is getting at. Unless
then I have my third question is, you said the dark energy cannot be detected because yes, because the solution is imaginary.
Yes. Okay.
Yes, but what do you think that there is another reason because of the so-called Gibbs fundamental equation, because your graviton is rotating, and the rotation subtracts from the energy, so that the total temperature of your graviton is 0 Kelvin, and particle or whatever with 0 Kelvin you cannot detect.
Okay, that's also very good. Yeah.
I like you can read it in my metric universe.
Because we cannot reach. Yeah, Gerd, this is very nice because we cannot reach absolute zero.
Page 87 and the metric universe, page 87.
Yes, but we cannot reach ever. So the graviton resides actually to the absolute zero, but we cannot go there. So this is a thermodynamic explanation. That's very nice explanation. Yeah. Yeah.
Thank you.
I have one question about the graviton. You said graviton is -2 spin, right? So something has to balance that.
Yeah, I very much like to show you again the slides, but it's this kind of presentation is very troublesome. So I have to vocally now. So Rajan, please repeat your question.
Yeah.
You said?
Yeah. So you said graviton has spin 2, right?
Not me. That's the theory of the of the standard model.
I agree. I agree. But something has to balance that, right? If it is something positive, something has to balance. There has to be something -2 also. What could it be? Anti-graviton?
Well, because it's an elementary particle, it has nothing to balance of.
Well, that's right. It has no antiparticle, but they do say it has 5 degrees of dimension. So you could have like -2, -1, 0. Just as spin 1 photon has -1 and +1 and 0.
Okay.
Degrees.
Yeah. So it will all add up to the.
I have now just to make a notion. Where's Christian? A notion. You heard about extra dimensions, yeah? All the theory about the extra dimensions.
Yes.
Yeah. So I can provide you with a lecture from a very famous scientist. It was 2015, where because many people have the idea about extra dimensions being something, you know, you have the 3 X, Y, Z dimensions, and then you have time. But no, they don't, by extra dimensions, they don't mean a 5th dimension, so X, Y, Z, and then another axis. No, 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 no. Because I was actually under this impression about extra, when they were talking about extra dimensions, I thought also the meaning I have X, Y, Z, and then have another axis, a spatial axis, so that pointing somewhere, I don't know what. No, they don't mean that. They say what they mean about extra dimensions, that there is some kind of vibration, very small, very microscopic, which we cannot see. So this graviton, this circular rotation, is an extra dimension, actually. So we are not, what I'm saying about my ideas now is actually an extra dimension theory. Yeah. So actually, every manifold, because standard model says that all elementary particles are pointless, dimensionless. So any theory that involves a manifold for the particle is actually an extra dimension theory.
Sure.
Maybe also Christian. So because I had also the false impression 1 year ago, I thought also that they mean by extra dimensions something another exotic dimension, I don't know what, tetrahedron, what. No, that's not what they mean.
No, but it still has to be. It still is a direction. It's just
no,
like
they're going to blank. They're going to blank scale. They're going
but it is still technically a direction, though. It still has to. It's still like it still needs to be an axis in space. Like otherwise, it means nothing. It still has to be a direction. No. It's like outside of the 3 spatial directions. I know what you mean, though. Maybe you think like, well, I mean, it could be just infinitely large as well. That could be another way of looking at it.
Yes, so you were thinking the extra dimension
compacted dimension.
It's rolled off, and
you have a wire. You have a wire, and for you, it's just 1 dimension of the wire. But when you zoom in, you will see that it's spiraling. So that's what they call extra dimension.
The subspaces itself move in the space directions as cells, and they are like a house on the cells of the geometry, you know, and in time. So a cell can move a tick in a time from a coordinate x000 to 001.
Exactly.
But what move is the whole house, and we're sitting in the house with our atoms, body, cells, and mechanics inside that.
Yeah, exactly.
And so you don't need further directions, but what you need is the geometry. Like you cannot do Lego in continuum. You have to get the constants of nature in I space. You need some Lego in one way or another, and the geometry is not compatible with relativity. So you encapsulate your geometry in a box, and that box is a subspace.
Well, I mean, if you're talking about directions and different directions in space-time, or time or space, I mean, sorry, then and then you have another direction, like a new dimension. That's still
but these 10-dimensional theories, which really think they have spatial in the sense of 90-degree upright to all other current axes before this, I don't buy either in. So this theories lead to nothing.
What direction is it going to be in? Or how does it work? Like it would have to be,
it's a matter of size. It's a grain. It's when you look in water, it looks fluid, right? But when we know water is not fluid, water is atomic. It's completely discrete. And how do the atoms create the fluidity? It's just in your brain. Just think of it. There is no fluid. It is just all hollow. Nothing. This is nothing.
Well, yeah, but you
brain constructs something you can swim in. This is very clever, actually.
In the universe, for instance, like all elements are just add an electron, and suddenly from you go from, I don't know, platinum to steel or whatever, and you have like.
But all forces are electromagnetic in the sense the desk doesn't, your laptop doesn't fall through the desk because the electromagnetic forces keep it rigid.
Yeah, not even sure how this ties into the whole directions thing. Anyway, so.
Yeah, easy because you have crystals in, and you have also some kind of crystals of other geometry. There are even time crystals, by the way. Physically proven.
Time crystals are Well, I mean,
you don't need a new time axis to have time crystals. It's just a structure.
Wilczek actually, the Nobel Prize.
I agree. I'm not saying time axis, but we're talking about new space axes. The Kaluza-Klein theory is a space axis, like a fifth dimension.
No, look, when you have these subspaces, what I in iSpace call 60 subspaces plus time, rotate with speed of light in its own. So you cannot give it a geometrical direction. They have no axis. They point in literally all axes at the same time. This is why photons are emitted in random direction and in experimentals, and not just always in one direction. If
well, you could say that we're actually rotating and it's static. Like that could also work, and that's the reason why we can't access it.
The mass is static, and the effect of the mass of the subspace is static, but not its information exchange with the neighbor subspaces. Everything is about information exchange, and as the subspaces rotate with speed of light, they can only exchange the information to the next subspace with speed of light. It's like a rotating door interlocked to the next rotating door. And by the way, that is exactly what Maxwell had in his book. What Emmanuel showed there with the rings. I know the logic on what you try to show there directly with a hexagonal structure. In the original book of Maxwell, it was hexagonal geometry. And you know the image of the original paper. I've read the original paper, and that is really cool. So it doesn't explain the bending of the thing, and that is why it was criticized in the original as unphysical. But if you have subspaces which are coordinates which can shift relative to each other in a 3D space, it's not unphysical. So what your magnet does when you indeed place it in space-time, have the metal powder just shows you as a detection tool where the lines are, but they are physical in the sense the lines are distortions in space-time.
Yeah.
This is a very, very good image, I think, what you created there, Emmanuel. That is, I really like that, especially equivalence of electrostatic and electromagnetic forces, because I don't buy in special separate electrostatic and electromagnetic forces. It's all electromagnetic, just from the reverse side of the space.
Yeah, of course.
So in iSpace theory, the 3D of the 60 subspaces are electric, and 3D of the 60 subspaces are magnetic, but they interchange constantly. They are never at rest. And that's why it is electromagnetic. And when you look from the 60A or 60B side, then it becomes what was formerly magnetic becomes electric, and vice versa. So it's only a definition.
From different sides.
Yeah, so, that is in a sense the geometry what you're asking for. So of course you can turn by 180 degrees and then you make a magnetic field an electric field. And if you wait for the next phase to come, this is exactly what light is doing when it's propagating. But light is also polarized when it's going forward, and not just horizontal and transverse polarized. That is just wrong. And it is not doing that because light wants to go circumpolarized, but it is circumpolarized because the whole quantum vacuum is circumpolarized. When light goes in a medium which is circular polarized, it goes a straight line in that polarization from its point of view. It's doing nothing.
That says many things. Yeah. So yes, for me, like the phenomenon of the flux suddenly coming out of the vacuum it says everything about that's actually a distortion in the vacuum. So I don't see a magnet as a generator of flux on field. It's just a
all these virtual particles are logically, mathematically real in the quantum electrodynamics theory. Otherwise, the theory wouldn't be that successful. But so they are not really virtual. That is the key case. They are a mathematical equivalent of what happens. We just need to find the better iSpace compatible mathematics to the same effect. So the electrodynamic effect is for sure real. But
literally, I may have discovered something along those lines for you that works a little bit with your theory. Like, I don't have an example of it at the moment, and I'm not sure if it would work on this screen, but yeah, maybe I should have prepared this. But basically, if you have a load of lines like a gradient, you know, the way we think of it, but it's a load of lines all pointing at one point. and you have that on your computer screen, which is rasterized with pixels, and then you using the scroll bar at the side of your browser or whatever, move it up and down, and you'll see a radial a magnetic field pattern.
Oh yeah, yes.
So it's directly out of this kind of pixelated world that you're talking about.
Yeah, that's due to the hysteresis effect of the LCD screen. You know,
yes.
They have the response time, and so when you move something linear fast, they cannot instantly switch over gradient, and they make this this shadow effect.
Yeah, exactly. So it's not really there, but I mean, it would be interesting then. I mean, obviously, there's polarized light being used in the LCD screen, so maybe there's some connection there with the whole thing.
Oh yes, LCD screens are polarized.
Yeah, so you can think of it maybe.
I believe they're circular polarized. At least mine.
Sorry, what?
At least my laptop screen is circular polarized. The TFT screen I use here, the polarization is circular, because I have some filters and can use this to see what kind of polarization it is, horizontal, vertical, or circular.
Oh, right.
It's I can't remember, either diagonal polarized or circular. I'm not sure.
Right. Okay. Yeah. Well, I think that the main theory about magnets is that, you know, if you get a hammer and you just tap a piece of metal or whatever, so and then all of the electrons in the atoms become harmonized, and they're all spinning in one direction.
Mm-hmm.
So I mean, I think that's the kind of main idea. So if you had if they all make up a gradient field in some way, I'm not sure if they do, but you could imagine some sort of, you know, rotating gradient field, which might create the magnetic. The magnetic field then, as it interacts with the pixelated space-time like iSpace that Christian was talking about, but I mean that's doable.
Yes. In my thought, all the three forces of the four, electroweak, which are actually two forces, electromagnetism, the weak force, and the strong force. That's three forces.
Yes.
The common characteristic is coherency. So whenever you have coherency, then you have the phenomenon of electromagnetism. But gravity is not quite a coherent phenomenon. So if we say in the picture we have about the graviton, you have now the photon ring, which is superluminal. You have the halo effect. The halo effect is actually the virtual photons. The very energetic photon ring here is the dark energy, which is not detectable. And then you have the singularity, okay, which is it's gravity. So gravity is actually the absence of all the previous energies. So that's gravity.
Okay. Well, I thought, I think the idea is really interesting. It's really cool. It seems to, I don't know, explain a lot of stuff, and it's very understandable as well. So these are all pluses as far as I'm concerned.
All them. So my final word here is that all the elementary particles we have, it's not the end of the story. So all the electron, the positron, the photon, they are all woven with electromagnetic flux, because I get a lot of the questions. So what material are these particles are made of? And my answer is not theoretical. It's very practical. It's electromagnetic flux. It's the same stuff. But what is now electromagnetic flux, according to my newest this outline research? It's aligned gravitons. So the flux, this thread which all particles are woven, is made from aligned gravitons.
Yeah. So I suppose you were talking about predictions and stuff in your slideshow. I'm not sure if I recall those, but how would you prove your idea though? Because I mean, it is.
So yes, this
experimental proof.
So this, as you have seen this presentation, there are new material which is not included in the actual. In the actual publication. Yeah. So about all these ideas about bosons and all that stuff, these arguments I used, is only for a future paper.
Fair enough.
Yeah.
Okay.
Now I will take a summer break and.
Yeah. Well, I would like to ask a bit about like your earlier research.
Without my wife.
Yes.
I go to an island without my wife and.
Oh, fair enough. You're not right. Okay, so
joking.
Okay. Right. Oh yeah, that makes sense. Actually, sorry.
I love very much my wife, and I go everywhere with her.
Okay, so I was going to ask you about your earlier research, though, that you mentioned in the slideshow. So the question was about, and it's a bit similar to Gerd's, but a bit different as well. So geometry of the spinner is 4 pi, you were saying, but you said that it is actually 2 pi, and the relativistic effect produces 4 pi.
That is one of my conclusions of my research, and actually, I mentioned it in the paper in the scientific research publication. I don't know, I can't remember now the name of it. The one which says the fine structure model of the electron shows that it has an actual manifold. That kind of title. And
yes.
Yes, and this is also a print. If you go to my ResearchGate page, you can find a preprint which is exactly about this topic.
I've read that. Yeah, it's very good.
Yeah. So yes, this is my research. That it's actually inside the lab frame of the electron. It's actually 2 pi. It's 2 pi, and then after I've proven this the simulation. But because the time dilation effect times 2 of the Lorentz factor, so what I did, I used my model for my fiber model of the electron. In the simulation, I put exactly this ratio of the trajectory of the revolution. So the electron has a z component, does a revolution in the z-axis, and has also in superposition a revolution in the xy plane. Yeah. So if you put spinor length, the ratio 0.866, actually it's square root of 3 divided by 2, and use tangential speeds with the same ratio for the longitudinal revolution and the latitudinal revolution, then when you use this kind of velocities and you calculate the Lorentz factor, you get exactly an Fs to Fr rotation, which is angular frequency of spin rotation to the revolution part of the rotation. You get exactly 1. When I did the simulation came with 1.15, and I said, "Wow, why not 2? Why it's not 2 pi symmetry? If it's 2, it's 2 pi symmetry. But why it comes 1? If it's 1, it came closer to 1.
Yeah.
So if it's 1, the symmetry according to the simulation did in my model is 2 pi, not 4 pi. But it came 1.15. So why 15, which is the inverse of 0.86? If you do the reciprocal, 1.15, then you get 0.866. That is why my initial assumption was that the two tangential speeds are set in the simulation at c. So the latitude part of the rotation to the longitudinal had the same tangential speed c. That was my initial assumption of the simulation that I am. But then came a fellow researcher, which is sorry.
Yeah, what's his name? Is it M or T? Or
no. Oh. Gin, Preston Gin.
Oh, Preston Gin.
Yes.
Yeah.
And we had a conversation. And he did a cosmological study and proved that the Thomas precession is the basis of all the universe. It has to do something with rotation. And he calculated the electron without using my model. He was using his own model.
Yeah.
And it's logical if you think about it. You have this fiber. It's going with the speed of light, the revolution. But the whole thing the whole thing, because it has volume, it cannot go with the speed of light. Yeah, you need a 2D surface like a fiber to go to with the same speed as the speed of light c. But if you have volume, mass, volume is the same thing, then you cannot go faster than light. So he told me that the speed is actually a square. So you have the revolution of the Z component, the revolution of the fiber, but then the whole thing, the whole manifold also rotates the XY. This is not at C. So if you put this, if the speed now, he told me is 8.66 of the light speed, then when you put that in my simulation, you get exactly 1.
Okay.
Okay. So in my initial simulation I assumed that the two tangential components speeds are the speed of light, and the ratio came out. The ratio is the G factor actually. Came out 1 instead of 2.
Shouldn't it be 2 if you want
1.15. But when I trimmed,
that's not really the question I'm asking is slightly different anyway. So geometry of the spin, that is very interesting though. So, but just to get back to the question, so if you have these two things, you have the geometry of the spinner has a 4 pi rotation, but it's actually 2 pi from the relativistic perspective.
Yes.
Wouldn't that mean you need to do a transform between the 2 pi and the 4 pi geometries, or how do you get around the discrepancy there between the two systems?
Yeah, I had also the same problem to understand this, but you need to understand how they measure this thing in the lab. So you have to, and it's actually, believe me, it's very hard to find the actual literature.
Oh, no, I read the paper on it.
They use Newton interferometry, and they measure the self-interference effect of a single neutron. It's like the double slit experiment, but with single photon. Yeah. So now they actually measure the precession frequency of not the physical spin we theorize that the particle has, but the precession, the magnetic moment, the precession it has, the angular precession, the gyromagnetic ratio. From this gyromagnetic ratio, they extract then the symmetry.
Which is 4 pi.
Which is 4 pi.
Right.
The last one, yeah.
Right,
that's all it is.
The relativistic thing says the reason why it's 4 pi is because of some sort of what did you call it?
In my theory, I believe it's because if I put the exact measure, these values I told you, and this ratio of the spinor, the length of the length trajectory of the spinor on the tangential velocity ratio equal with approximate 0.866. Then the spinor produce a Lorentz dilation of gamma 2. Yeah.
Okay,
so
but then
this is a time dilation effect. So the 2 pi rotation is actually in the particle frame. It's a normal 2 pi rotation, nothing unnatural. But due to the time dilation, it appears as 4 pi. In the last
but doesn't the manifold show like the reason why? I mean, I haven't done the I haven't tracked the manifold to see how it transforms under rotation, but it looks like after 2 rotations, it comes back to the same shape, yeah. But you wouldn't need that if you have a relativistic thing, or would you?
That is relativistic, Christopher. I have in detail analyzed
so they measure the time
session from.
It's hard, yeah. No, it's very hard to.
Yeah. I'm getting. That's why I'm confused about it.
Is it possible?
You have two movements which move against each other. You have the precession and the counter precession, as it's shown by the paper of Preston Gunn. So they have a peak point. There's a curve going up and down, and then the maxima is exactly giving the relativistic factor of 2. And that's why it's integer. It's also why it fits psi-space theory. It wouldn't fit if it was
no, wait a second. Isn't the point of the Preston's work and the other one that it only turns once, but it looks like it goes around twice because of the time.
Yeah, no, this is a real relativistic effect. You in forward motion, relativity tells you shorten yourself to have a shorter distance to come to the target. That is what the saying that time is slower. Then you have a longer way to go, because at the same time, from an external observer, it doesn't matter. It's like A is equal to B divided by C. So just
then I kind of feel like if that's sufficient enough to explain it, then you don't need a geometry that has like
this is what I'm saying. You don't need any space-time geometry to do that. This is in plain 3D. Preston believes in 3D universe because his stuff works in 3D. It doesn't need extra dimension. It doesn't need anything of string theory. It is just plain 4-dimensional.
Or you
still need a manifold, however. Even if it's a relativistic effect, you need a manifold. So the spin 1 is a circle, but the spin
but Thomas precession is a special thing. The manifolds of Thomas precession have never been properly analyzed before Preston looked in detail at that, and Thomas did, of course, that in detail in his paper.
Yeah, Preston Jean was very helpful. Of course, this part is not in the initial paper. I just published it with the result 1.15. Yeah.
No, this is really interesting that you come to a different factor, and I mean it's also very clever of you that you take the inverse. In iSpace, I constantly take routinely all inverses because only then you see these resonances. When something suddenly becomes an integer or a quarter or a fraction or an eighth of an integer, you cannot see that in the Kehrwert, in the inverse. You have to check always both, and then suddenly you say, "Wow, this is discrete. Why is that discrete?"
So
pi and gold ratio is divided out of the geometry when just integer ratio stays. Then it's becoming discrete.
All right.
Exactly. So this is a case.
There's one thing that Thomas precession that explains it without, it's just relativistic. And then the other usual expression is explanation would be some kind of belt trick sort of geometry.
That has nothing to do with each other. That for the belt trick, you need extra dimensions to bend the belt.
No, you don't. No. You can do a belt trick.
Explains the half spin of the spinner of your electron.
Or I think you can even do it with your arm. You don't need extra dimensions.
The belt trick is just a visualization of the half spin of an electron, the half spin spinner. Yeah, that's
which is also what your model shows. The toroidal thing shows a similar 3-dimensional rotation, which is basically the belt trick.
It's the belt trick, but which is adapted to a torus now.
Yeah,
it's a belt trick, because we say that the manifold is a torus, so it's adapted in this spherical.
The problem with these belts I have is that God doesn't prefer the x direction. So when you have something like the belt, you make it epsilon symmetric and
to explain the same.
That you cannot do it with them.
Do you know what I mean? You have the belt trick explanation, you have the relativistic Thomson precession explanation, and that one kind of says that the other one's unnecessary in a sense. So that is what I'm kind of confused about. But
to expand on
the other question,
which was the one of your core points.
Rajan, you were trying to get in there, I think.
Oh yeah, to expand on Christopher's question, I think it could be a chirality thing. I'm actually analyzing this. I mean, to some degree. I think we will have some more discussion about Clifford rotation and Grossman rotation. These two are two different rotations. I am putting in one of the papers.
Well, the gravity is very simple. It's just a circle.
Yeah.
So the Grossman clockwise or anti-clockwise. Yeah. It's nothing special about the manifold of the graviton.
Yeah.
And that's why it's fundamental. The most fundamental. The more fundamental you go, the more simpler it gets. According to me, I don't know.
Yeah. No. The question I'm asking is the chiral thing. If you put a chiral rotation left and right, you cannot complete in 2 pi if you actually rotate. You cannot complete in rotation. That's why you have the manifold effect.
Yes.
3
Yes.
to 4 pi effect, you know?
Yes. Yes. The
So it's a
manifold
chiral thing. It could be a chiral thing. It could be chiral. Because chiral, you know, you cannot, if you rotate, because of the mirror symmetry, it will not match. So you have to go again another rotation to match it. So it's a chiral thing. So the electrons could be chiral. One electron could be, you know, chiral of the other one, or particle. You know, it could be chiral particles. That's why you have muons, all these coming into picture, because like you mentioned, I think you are much closer, Emmanuel, to understanding electron than anybody else. I think
No,
you know.
no. I don't. That's not for me. I
Yeah,
don't
yeah.
know nothing.
Yeah,
I'm a guy that think that the electrons, all this in my, you know, the fibers in my model of the electron, these are just flux, and the flux are made from coherent.
Oh, yeah.
Coherent gravitons, and not actually, we don't see the dark energy of the graviton. The flux is actually we observe is the halo of the ring. Do you know this cloud? This is what makes the flux. But inside is the gravity. Each flux is like a straw, you know, straw drinking cold coffee you drink. So it's a straw. So the straw, the outer side, is the dark energy. We don't see it. Inside the hole is the gravity, and there's also some kind of cloud around the straw, and that's the flux we see. So the flux itself has gravitons. It's empty inside, and has the dark energy. So dark energy is everywhere. So it's all embedded in one. In one particle, you have dark energy, you have the gravity, and you have the 0-point energy, the flux.
The dark matter also comes because of the gravity effect.
Dark matter, that's just a speculation. Just an idea. There's no analysis actually.
Yeah. Two things
but I'm sure about dark energy. I'm sure about dark energy, about the connection of dark energy and this intrinsic superluminal property. Because you have one property that explains almost all unknown problems. So it must be taken seriously. Why only adding one property, superluminal property, to the vacuum solves immediately so many problems?
I think I will quote your paper because the distortion, I agree with you about the distortion, because it's actually a distortion of the vacuum energy you said because of the magnetic effect. And I am coming to the same conclusion with the hot PDP mechanism. I think I can quote your paper also about the distortion aspect, because that's one of the final things I have, the new paper I have. And two more things. And your explanation of graviton spin 2, now I understand a little more, like why other particles should be there, because there is no antiparticle, so other particle has to add up all the spins to match the spin of graviton. So the graviton could be the
most fundamental,
the most elemental particle, the primordial. Yeah. The other aspect of the dimension, the new paper, I think is coming up. I already sent, and then I'm working on the final paper, the fourth one. The 5 dimensions come because of a whole new thing. I come up with the idea of consciousness. Is one of the dimensions. Consciousness. Then you have environment. You have world line, timeline, and also you have the state of the clock. They form the 5 dimensions. So it's not spatial dimension. Like many of you are agreeing, there are only 3 dimensions spatially.
Okay, that's we have to discuss, because I don't believe in consciousness. I have problem with
the mind.
Consciousness. What do you mean consciousness?
It's an observer, essentially like an observer, you can say. You know, observer. The observer.
The observer. The
observer. But you see the Sabine Hossenfield has said the observer has to be organic, or it could be inorganic. Can the observer be inorganic? So then that's an excellent question, because the observer can be inorganic also, according to the quantum thing. So that
you have no
apparatus,
a human thing in any way. It's about measurement, and the measurement action needs a device to measure. If that are your eyes, or if it is a machine with a photodiode.
I agree. Yeah, that's why I say consciousness, because the observer has to consciously measure that? You know?
Even if it's a mechanical device.
Yeah, even if it's a mechanical
device.
Yeah, something has to consciously measure that. That's why I call it consciousness.
If you allow, I would only have one question to Emmanuel.
Sure.
Yes.
Go ahead.
Sure.
I say, first of all, I liked what you presented. So if this sounds critical, it is meant for critical thinking. This is not a critics on the concept or anything. Yeah. So I'm not putting these things. So I warn you up on that it sounds critical. So of course we have energy conservation, and with no doubt the energy conservation, what you showed on your Higgs example, when the two photons are going with 56 tera electron volt, or don't remember the number now, need to come from something which had some of that energies before. Now, when you have a superluminal model of gravitons, I actually like the idea. And I can understand how a superluminal thing, maybe with twice the energy, just comes to exactly the two photons, which are then split off purely from logic. It sounds nice, it fits well. But what I have the problem with is, what is the reverse mechanism? If we cannot exceed the speed of light c in any way, what the hell creates gravitons? And when?
So
you see my problem. Gravitons emit the two photons, and this is a process under certain circumstances when the Higgs is intermediately created, which I also not believing in a particle as such. But the mechanism of the Higgs is surely necessary in one way or another. Otherwise, quantum electrodynamics wouldn't work.
Yeah, of course. The Higgs boson is a particle.
They measured something. They don't really know if that. They agreed it is a Higgs boson, that the whole work in 20 years of accelerator measurement doesn't look bad. But this is another question.
Christian, the real purpose of detecting as I said, the Higgs boson was not the Higgs boson itself. It was the mean for verification of the Higgs field. That was what they're most interested in. The Higgs field, which is omnipresent, is, as you know, what they're after. They're looking after.
For me, the Higgs field is something like the ether. It's just a different name for the same thing. There needs to be a mechanism, not an abstract field. These abstract fields I don't buy into.
Yes, if you ask a particle physicist working in CERN, they say, no, it's not the ether. It's totally different.
Yeah, I know.
But they're wrong. Say the Higgs field is something different. Yeah.
We need to find a mechanistic way of everything. Their mathematics is giving right answers, but they are by no means the geometric root cause of anything. They're just giving the right answers with very complicated mathematics.
So before 200 years ago, they said the luminiferous ether. Yeah. You could say that my speech here today is not the superluminal. Yeah, of course it's luminiferous ether. It's more like the superluminal ether.
Yes. Yeah. No, this is not a pun intended. Yeah. So
back to your question, if I understand correctly, if I understood correctly the question now about the conservation of energy. So when the two matter in the LHC experiment, when the two matter beams collided, and of course, the impact energy was 14 tera electron volts, because they also produced a sprinkle of all other Feynman diagram particles. But the minimum energy, so imagine that that you have glass. What is the minimum energy you need to break the glass, to make an imprint? So this energy was this about 126 giga electron volt. Yeah, so it's the minimum energy to break the vacuum and make this imprint of the Higgs boson. So I don't say the Higgs boson is not real. Of course, it's a particle. It's a scalar particle. What I'm saying is that there's another particle behind the Higgs boson, which is the actual quantum vacuum particle, which is the spin 2 superluminal graviton. And why I'm saying this? Because it's my intuition that spin zero is not a physical particle. It cannot be, it's unnatural. Spin zero means it doesn't rotate. It has no vibration. It has no manifold. It has no sides, nothing. It's totally unnatural. So the Higgs boson was just a snapshot of a graviton which suddenly, because the impact stopped for a moment. So you have a static imprint of a graviton actually. That's all. So, but the energy, this combined 126 giga-electron volt, is not the energy of the graviton. It is not the full energy. It's the energy the graviton lost momentarily and came out from its superluminal energy state. If you make the calculations and see that the QED vacuum, the QED prediction of the vacuum is 120 orders larger than the actually observed, yeah, then of course the graviton is not just 100. It's stupid. Just the energy the graviton lost momentarily and propagate to a Higgs boson, then to 2 gamma photons. That's the 126 giga-electron volt energy. Of course, the graviton has much larger in its normal energy state. It has tremendous energy. It's not just 100.
I agree. So what I can see is how the reverse mechanism, either after Big Bang, when there was a Big Bang, or whatever the quantum, when quantum vacuum is eternal, then there's still, if every now and then such events create photons, this thing would evaporate one way or another, like a black hole would evaporate if only a few would, by such mechanisms at these energies, they would be missing. So there needs to be a time reversal mechanism to take photons and make a graviton out of that. And I cannot see how that works, purely from a logical point, because you would have to accelerate something to a superluminal speed to create such a thing. Then this is my logic, which is where my logic.
The two spacetimes are totally discrete, but also embedded. So they're in superposition. They are discrete. The superluminal spacetime of the graviton is a discrete spacetime, and our spacetime, the luminal spacetime, is they're discrete. They have a boundary, but they are actually in superposition in the same Cartesian space. Yeah, I don't know if this explains what you're asking.
No,
so
because
the time reversal mechanism is
your model. The graviton destroyed when the photons are created, or is this just its speed converted to zero? It's still there and has triggered in the superposition that what we perceive in the measurement device of the LHC, two photons going off in opposite directions. Because this is where the energy comes from, is from the accelerating beam. We put a lot of, this is not an energy problem, we put a lot in the acceleration of the things. Yes. Things collide, so there is no in any way energy problem. But nevertheless, if things are superluminal by design, I say now by design because you designed them this way in your model, okay? Mm-hmm. Then they need to interact in one way with the non-superluminal stuff, either by position or they touch each other, or whatever happens, they transfer momentum, they could transfer information. So but when they do that, and after doing that, and we see the photons, I would say all quantum processes so far we have are time reversal. And at least for a very short time, all of them, no exceptions. That means that we would have to have some mechanisms to take the photons and see how to get a graviton.
So you're talking about the CPI time symmetry.
Yeah.
Charge parity and time reversal
kind of
symmetry.
Things, yeah. In general, yeah. So
individually, you can have combination of one or two broken, but all together must not be broken. Yeah?
I know.
Yeah.
So that's a good
question. That's actually a very good question. Yeah.
Yeah. So expand on Christian.
So, I don't know. The answer is I don't know.
Yeah. But how about monopoles? Christian, how about monopoles? Can monopoles create that graviton? There are monopoles in the superluminal thing. Can they create the graviton?
Interesting input, because I'm seeking for a mechanism. So when monopoles could be the mechanism to accelerate or build the bridge between the luminous and the superluminous, and then that would be the gateway in one way. So
So my thing
the problem is you cannot find magnetic monopoles. That's a problem. Magnetic problems.
But you cannot see monopoles because they are faster than speed of light. I mean, like I said, if anything goes faster than speed of light, nothing comes back, so you will not see it. You know, it's one way. It goes one way.
Either it interacts or it not interacts, and Emanuel's thing interacts with the set PE, so with the 0-point energy, one way or another. And the 0-point energy is very real. We don't know where it comes from, and it is a very, very good explanation for such a thing from a model point of view. Yeah?
So
it doesn't make the set PE magic. It mathematically is magic in the quantum equations. And you have to accept it. But this is a thing which gives a much better picture with what Emanuel proposes here.
Yeah.
That you have micro black holes which give the gravity, and outside of them is that what we call Zitterbewegung.
Yes.
That makes sense. But then this Zitterbewegung around that micro black hole is a form of interaction with 3D space.
Yeah.
What is Zittering?
It's the link. It's the link of the two space times. Yeah, it's the Lorentz invariant part. Yeah.
Right. Okay. Interesting.
So I'm very glad. That's the good thing with any research, that's not complete. So you have to work it and actually tweak other people to work and give ideas to other people's research. So,
yeah.
I agree.
A perfect theory is not a good theory.
Oh, yeah. I agree.
I'm not claiming for a perfect theory, but just if you personally have a model for that or have thought about this problem before, that is all what I
think we have to check with the monopoles and also the fact that
the graviton is a monopole.
What is
a monopole? Is it a monopole?
Yes, not a magnetic monopole. It's a monopole. Yeah.
What kind of monopole is it?
It's just one pole. It's one hole there.
It doesn't have any charge.
No charge. 2 holes.
Would you argue that a black hole is also a pole because it is a miniature point, mathematically 0, but physically minimal distance?
We assume that in our model with the Emmanuel, I use a micro black hole as vortex.
Yes, I remember. Yes, in the paper we did together.
Yeah. So there is one spins this way, one monopole spins way, the other one spins the anti-clockwise.
Yes.
So you have the 2 spins.
Region, the circular motion creates also the vortex. If you have a material and you make how you create a vortex, you just make a
I have another question. Sorry, do you want to get in there? You haven't said anything yet. Do you want to?
What happens to the graviton on the collision? Will it be destroyed or remains? Or does it remain? Yeah.
Sorry, Gerd, I don't understand. What happens to the?
What happens to the graviton on the collision in the accelerator? Will it be destroyed or?
So it decelerates. It loses momentarily its angular momentum. I mean, the speed, the angular frequency is dropping down, and it's phase transitioning. It's a phase transition mechanism. It's the case, the graviton decays to our space time.
But it exists.
It becomes a photon or
it still exists after collision. Okay. Yeah.
Okay.
Thank you.
Emanuel, one thing I forgot is actually a second question. Sorry, it's the last one I have, but that is an interesting one. Gravitons are proven to be guaranteed not faster than the speed of light due to the experiments done with the
translational motion. They are not tachyons.
Yeah, no. Wait. Don't get wrong by my language. So the word graviton is reserved, while not experimentally verified, that gravity in this kind of models is not faster than the speed of light c. And that has been proven by the LIGO arms experiment. Yeah, this is really verified. So they had cosmic events of collisions of neutron stars and black holes, and the light visible stuff came in about the same time frame as the gravitational effects of the ripples they saw in the LIGO arms interferometers.
Do you know what is happening beyond the event horizon? Are you sure what happens in the black hole?
No, I'm not claiming either way. What I'm trying to state the question. So when the LIGO is right that they saw the ripples in about the same time when the light comes, then the ripples were transported to the mechanism of the LIGO detectors with about subspace or speed of light mechanisms. Now, when you say gravitons, you should probably find a new name for these things when they're superluminal.
So gravitational field.
Gravitons, then because this is a word which is already tainted with that what the LIGO people say is guaranteed.
No. Please let me explain.
But you know what I mean.
Yeah, I know what you mean. Let me explain. Yeah, I have to go to the presentation back.
Oh yeah, no problem. Sorry. Hang on a sec.
How you do that now? What time is it, guys? What time is it here in your place?
It's nearly 11.
3 hours.
Now,
We are about 3 hours.
Yeah, 10 minutes to 1 after midnight.
In Munich, it's 10 minutes to 12.
Share
I
screen.
spent about 3 hours.
Share screen. So window, entire screen. Window this entire screen. Yeah. Sure.
There you go.
Worked.
Okay.
I think we should save a connection time.
Can you see the presentation now?
Yeah, we can.
Yeah. So you have transverse waves. That's what LIGO detected was the transverse waves, which actually is what was said before here about if you have the field, the photo field, the virtual photons, and you tap here one point only, then you create transverse waves that propagating with the light speed. But there's another component to the vibration, which are these guys here, longitudinal. So the LIGO experiment detected the component here, the transverse waves component, which is of course is at the speed of light. Okay, this animation here. But you see here, even if we say that this is the vacuum molecule, an analogy, you have the circular motion here, but you have also the z-axis is the transverse waves, the circular waves, but you have also this axial radial waves, which is the longitudinal part. And this is not at the light speed. Actually, this part of the wave is that what gives the instantaneous action at the distance of between the spin of two entangled particles.
So to get it right in this model, the peak of the wave is superluminal in this image.
Yes. Well, not the peak. You see this motion here, the water molecule is doing. You have the Z component, which is the transverse waves, and you have the longitudinal wave, which is pointing to the to the same direction as the pointing vector, the energy vector. So the longitudinal is actually in the water. This part here is the sound wave, the sound speed. So the sound speed, the radial wave here, the radial pressure waves, is actually the sound speed inside water. But if you do, I forget the model now. If you want to now to calculate the Z component of the transverse waves, it's much smaller. You know, the sound inside water is 2,000 meters per second, about that value. But the actual transverse waves, which are these waves, the Z component, are much slower. So what the LIGO experiment discovered is this here. When you tap here the static field, you create a transverse vibration. They didn't discover the longitudinal part, which is this part, which is this part of interaction, which is the superluminal part. I don't know if
I agree with that in terms of
so
gravity would have to be instantaneous.
You poke here the water. You poke the water. You have the transverse waves. Yeah, the gravity, of course. And the static field. By the way, the static field has infinite velocity. The static field has infinite velocity. Only if you make if you poke it, you get a distortion which propagates with the light speed. But the distortion has two parts, has two components. Has here a transverse waves component, which are the circular waves, wavefronts, but has also a pressure component, a longitudinal component. Well, this longitudinal component is the hidden interaction, which causes all this funny behavior of quantum entanglement, superposition, and so on.
Yeah, I completely agree that there needs to be an instant action at a distance. I recently read an extremely interesting paper on ResearchGate, which said they did a classical Newton analysis of the solar system, and it would not be stable when they calculated relativistic. It is immediately stable when they calculated Newtonian. So what they calculated, and it could be the years now wrong what I tell you, but in principle, qualitatively, they said we have 5 billion years of the solar system and it's stable. No matter how long it took to create it, as it is now for us visible. And after 100 million years, it would already become unstable when you calculate it with relativistic effect, because the time delays give effects like butterfly effects to the chaotic motions of multi-body systems, and it flies out and is not stable anymore. So like the moon is in full sync of its revolution with the Earth, and the Earth is in 2 to n syncs with the Jupiter. And
I think I read also the same article you are referring to.
This is a very clever article, by the way, because this is a simple analysis that they simulated the solar system over 100 million years, and it's not stable if you don't assume it Newtonian. I mean, that means something. This is really, really impressive.
Yeah, I have another question about the gravity. Wait a second. Could I just ask a quick question now?
Yes.
Oh yeah. So this is probably a really a quick question. Let's put it that way. So I'm just curious about the gravity. Gravity pulls things together. Dark energy pushes things apart. But then
something like radiation repulsion force. You have radiation pressure. If you have this
pressure. So it's radiation from the particles.
That's the anti-gravity. The same particle of gravity has all three components. Has gravity, has energy, dark energy, which is anti-gravity. It's the repulsion effect that expands space-time, which is responsible for the expansion of the universe, of space-time.
And
it produces also the gravitational effect. So it's all in one. In one particle we have everything, and we have also the 0-point energy, which is the 0-point energy, the cloud. The cloud. If you remember the picture of the graviton, you have the energetic ring, you have the singularity in the center, and you have this cloud. So
you're not saying
the dark things inside is gravity. The energetic bright ring is dark energy, and the 0-point halo, the noise, is electromagnetism. Whenever you have coherently alignment.
So you don't think that there's a problem like with the one particle? Like it seems like it's in competition with itself almost. Like that's not an issue.
No.
Okay.
It's God, the Son, and the Holy the Holy Spirit. It's together. It's all together.
Yeah. Okay, that's fair. Yeah, actually, funny enough, you should mention sort of
gravity.
Theology. I think it's interesting that you now have. You're talking about the ether or space-time as being like a solid, like glass. That's your analogy, I guess. But in some ways, like in the Bible, doesn't it talk about the firmament? So you're bringing back the firmament here, Emmanuel.
No, just glass. It could be water. It could be water. It's something.
Okay.
Yeah.
That's fine.
Yeah,
So
it's a condensate. It's a condensate. That's all.
the glass model is not wrong because the stiffness of recent analysis shows that it's harder than glass, the quantum vacuum, actually. This is one of the riddle questions they have.
That's amazing.
So, yeah.
Yeah,
So
even Maxwell says magnetic permeability and electric, the speed of light depends, like a medium, the speed of sound depends on what? Of the medium, yeah? The speed of sound inside water depends on the medium, of the properties of the medium. The same, the speed of sound in iron or in wood depends from the properties of the material. So, but if we have now a materialistic view of the vacuum, and it's just a type of energy, of unknown energy, the speed of light is dictated by these two properties, and it's not mine saying, this is Maxwell saying, by the magnetic permeability of the vacuum and the magnetic electric permittivity. Yeah. So this is, you can imagine this analogy like the elasticity or stiffness Christian told you. Some similar property like elasticity and yes. So I use the glass analogy more to demonstrate the Higgs boson.
Okay, but if you have like a very dense
it's like breaking the glass.
Okay, yeah, but it's still there. I mean, it's part of your model, like, you know, so you could look at it that way. I mean, if you have a very dense substance anyway, you could have potentially particles that should move at the speed of light moving significantly.
Yeah, but why? But if it's very dense, why we don't feel it? We should be dead all if it's denser than normal matter. The answer is because it's flash. It's a flash. You know, you have seen the Flash movie? It's vibrating very fast, so it's getting out of phase, and then he can put his hand through wall.
Oh,
the Flash,
yeah.
you know,
This was another
he's
issue
vibrating his hand very fast, and then he gets out of phase of the wall and just put through his hand through the wall.
Yes,
so
yes, yeah, I know.
Quantum tunneling.
Well, that kind of brings me back.
That's why.
Sorry, it brings me back to the end here. Oh, sorry, there's a delay here. So it brings me back to the end point of your slideshow, which I was going to talk, because I think it's interesting. This week, or no, maybe not last week, but a couple of weeks ago, we were talking about the idea of how to back engineer UFO propulsion. Sorry.
Oh, really?
Yeah.
Yes.
Right. So, because it's very topical at the moment with Arrow and all of these different groups starting up in the US, and all of the, I think they captured a video footage of a spherical UFO over Mosul using a drone. So yeah, it's a big deal.
My proposal about the FTL drive is not similar with Alcubierre's. You know, I
noticed that. Yeah, because apparently
saying about shrinking space-time in front and extending back, but he never makes any reference what happens to the vacuum. My model is just displacing the vacuum all around.
Yeah. So it's much closer to what because the Alcubierre drive, if I'm saying it right, isn't feasible anyway, because what gives the motion, the gradient, just doesn't work according to.
I don't know, maybe, but I don't know. But it's Alcubierre did also a qualitative analysis, and he calculates that he needs the energy of the whole galaxy to create this warp field. So then the more research, FTL research done actually recently, and they have now an equivalent with similar to Alcubierre drive, but they need the energy of 2 Jupiters now to make this kind of warp drive.
Oh, okay. Yeah. Well, actually, yeah, it could work. I was just thinking of that doesn't really matter, I guess. It was Sabine Hossenfelder's, one of her videos, they were talking about how, you know, you have the gradient behind, which is expansion. You have a gradient in front, which is a contraction. But then where the craft actually sits, there's no gradient. But if it's close enough to feel either of those forces, then it should move. But if it's the one generating the forces, then maybe it's a bit like having a magnet in front of a cart, you know, trying to pull yourself along.
Okay. So I tell you now my idea how is it my idea how is this possible to create this vacuum displacement field.
Yeah.
So I will actually send you a 2015 very interesting lecture by a guy, which is actually a scholar, an academic,
Okay.
of this idea about an FTL drive.
Oh, cool.
And yeah, I will send you. I will send that guy to you all by mail. It's very
Great.
interesting YouTube lecture. Yeah.
Well, this was the other point.
My idea has to do with a blank frequency. You remember this this equation before about the blank frequency, which combines the gravitational constant with a Planck constant, and the speed of light, square root of speed of light over 5 power of 5, and the Planck frequency.
Okay.
Yeah. So I have to show.
It was in one of your slides towards the end.
Yeah, you have the same value like in my model. Exactly the same value.
Yes.
Cool.
Yes.
Guys, I have to excuse myself. I'm running out of time, so I had only the 3 hours today.
Okay.
To participate and having talked to all of you. We not see next weekend because I'm in Porto there with my son, a short trip. And I want to say very much thank you to Christopher for doing the recording today, but also for having the Newgrange display. I was at Newgrange, rented a car, it was fantastic, sensational. Nice.
Oh, good.
Very sorry that there was no time to meet you when I was in Dublin, and probably next time.
Yeah, or I might travel to Germany
to visit all that. And,
yeah, to drink some warm Irish beer, Guinness.
We drink cold beer here.
You Germans, I believe Germans don't like British beer. Yeah.
Yeah, but the Guinness is an exception.
Ah,
yeah.
It's
okay though. I'm drinking this.
Otherwise, you're right. So thank you so much, and have a nice evening.
Okay, have a nice vacation. Enjoy your vacation.
Bye.
I will finish too.
Okay. Yeah.
Thank you. It was very good. Goodbye.
Very nice questions. I like them. Yeah.
Thank you.
Well, thanks, Gerd. Good night.
Right.
If I may ask one last question.
No, I want to ask my Christopher's question.
Yes.
Okay.
The last point I was going to make, which was, I found this kind of quite interesting. So you were talking about.
I believe how you could create this bubble of lower 0-point energy vacuum. How you could displace the nominal value of the surrounding vacuum energy and make some kind of bubble of finite thickness, which the vacuum energy is lower. So it's like this air bubble going through a more dense medium. So I believe the trick is just it's not complicated.
Right.
So I believe the trick is the following. Just to go to the slide. You know what? Yeah.
Oh, if you can, yeah. Hang on, let me see.
Share screen. Yeah. Window. There screen. Yeah. Share. So this, I believe, the answer is here in this equation. What? This here.
Yes.
So,
all right.
Yeah. So this here is the Planck frequency. It uses the speed of light, the reduced Planck constant, and the gravitational constant. And this is actually the maximum energy we can observe, because this is the maximum electromagnetic energy we can observe. So any vibration higher than this, harmonic oscillation, it becomes invisible to us. So, and why this actually is the speed of all? So it refers to a vibration which is equal to the speed of light. Yeah, it has the speed of light inside here. So any vibration faster than this frequency, which equals faster to the speed of light, as you can see from the equation here, is totally invisible to us. So it becomes actually a black hole, a quantum black hole.
Right.
Right. So the idea is to fasten inside the hull, the hull of the spacecraft, to make it an antenna, and to try to transmit higher than this frequency. To go to higher than 2.9 40 times over 10 hertz. If you can succeed to make this kind of antenna, so you make here an antenna, a dipole antenna, one pole of the antenna is the hull of the antenna, and the other pole of the antenna, it's a dipole antenna, it's just popping out here. And you try to make a static a radiation field around the ship, which has a frequency higher than the blank frequency.
Would that kill everyone?
That will no, because you are in the same pole with one pole of the antenna. You use the ground that you have heard about Yankee antennas. So you have the ground, you have the reflector. You use the hull of your spacecraft, which will be metallic and will isolate you, will shield you from the radiation. So it's the radiation is only going outwards, not inside.
Like a Faraday cage, kind of.
Yeah. Yes.
Okay, I was just thinking because of such the high energy involved, like the hertz.
Yeah, of course, you need energy, but I'm not sure if you need the energy of 2 Jupiters.
Right.
In case of together drive. Yeah.
I see what you mean. Yeah.
Yeah, but
well, the thing I was going to. Sorry, the thing I was going to say about this relating to UFO propulsion, and also just specifically this image that you have on screen here, or did for a second, but is about the, the way you say when you switch the field on, the ship is going to be invisible. That instantly reminded me of a book called The Philadelphia Experiment. Have you?
Oh yes, of course. Yes, I've seen also the movie. It's
the
one
movie
of my favorite movies. Yeah.
Great. Yeah. Because the book is great if you can get your hands on it. I think it was written by Charles Berlitz. Indeed it was. Yeah. And he discovered that he was doing research into the Bermuda Triangle and UFOs, ancient civilizations. And then he found out about this. It was like a rumor, and people were like, oh, yeah, look into this. Some ship is gone. I think it was Tesla and Einstein was the myth surrounding it, that they had created some sort of invisibility cloak around a ship. So it was meant to just hide it, make it radar invisible, but then it actually made it invisible was the concept. And then it was also able to
travel space-time, travel back to space-time, yeah?
Right, yeah, it was able to move through time and such. But then also there was people on board the ship, according to the story anyway, and they found very much like what you were talking about with the Flash movie. They were able to phase through the matter, and go through the walls of the ship, and some of them even got stuck inside the ship because of when it rematerialized in a different place. I just love that. I find that story very interesting because of the psychological effects that people suffered afterwards. According to themselves. I think there was a guy called Carlos. Anyway, I think he was just called Carlos, and he was saying I think he was still traveling through time, even though.
So you read the actual book, not just the movie. You read the book.
Yeah, I think you could get it online, or you could get it through Amazon.
Can you send me a link? Can you send me a link?
Sure, I can look it up for you and send it on. Yeah, I used to have it, and then I gave it away.
It's a paywall. It's under a paywall, or just you can.
Oh, is it available? I don't know if it's still in print, but I'm sure certainly.
Can you also send me one, Christopher?
Yeah, I can send you on a couple of different links. I think you can. I'm not sure if you can get the book as a free PDF, but I will send you on a link for for the probably the Amazon. But I can send you on some related stuff that is free, such as there's a guy called Jessup, who was really important back in the old days in the 50s and 40s and 30s. to do with UFO research, and he flew to South America to find these big holes in the ground that he thought had some connection with UFOs. And then I think he was the first person who got contacted by this Carlos guy, and Carlos sent him loads of
yes, the Carlos. Okay, the Carlos case. This which was it's a mystery because he came and then no one. He wrote some papers up which we and. If you read the Carlos, now which I remember, he's talking exactly about this, displacing the vacuum.
Oh.
Yes.
Okay.
This Carlos guy, this Carlos engineer, which is a mysterious person, he's talking exactly about this. He's not explaining why you have to displace the vacuum, but this is actually the trick for FTL drive. He's saying you have to displace the vacuum, but he does not explain how and
yeah, I think they talk about that in the book actually, Manuel. They talk about big degaussers or something like that. That was I don't know if that would help, a degaussing field or something. But
Gaussian.
Or well, I'm pretty sure in the book they talk about something called degaussing.
Degaussing.
Yes. Carl Allen letters they're called, but I think his name is Carlos Miguel Allende.
Yeah, this guy, Spanish, Mexican guy, somewhere.
Yeah. So I can send you a link to that because that's quite interesting, and he talks a lot about different aliens in that, in those letters, and he gives them different names. So there's like the L ones and the S. Let's say it's LE.
Yes, it's very. All this is very interesting. Yeah, I know.
Yeah. And so what he said, like basically it's an acronym. So it's like the LBs, let's say, and the
the grays and all this stuff.
Right. Yeah. So I think I thought the L might stand for lizard. And
okay.
I think he had
I like lizards.
Yeah, something like Saurian. Yeah, but then someone did figure it out what they stood for. I just can't remember. But apparently, so you have these different types of entities, and they're flying around in these craft. And
yes, it's very interesting because you know, even if you are inside the atmosphere by using this kind of vacuum displacement, there's no really any difference between if you are in outer vacuum space or inside water or inside air. For you, it's no any difference because you displace the vacuum, so you don't have any other materials. Doesn't matter if it's air, water, or the vacuum itself. It's the same. So you will attain still superluminal speed inside the atmosphere and inside water. No problem.
Oh, so I have one question related.
Because if you remember, one of my most fundamental conclusions is that light and matter cannot exist without the vacuum. So if you displace the vacuum and there's matter inside, there's no matter. It's
of course. Yeah. No, it's very interesting.
What you talking?
Yeah, I have one question. What is evaporation? Won't there be an evaporation problem? Can't it be evaporation?
Yeah, you're Hawking evaporation of the black hole.
Yeah, inside the people inside that FTL spacecraft, which is normal thing, people can travel, but it couldn't be evaporating because of this differential field. You know, there's a differential field, so it could create evaporation problem. That's, I'm thinking,
the whole ship could evaporate. Is that what you're saying? Because there's no pressure.
Evaporate. Yeah.
I think they don't go nuts.
It's protected inside the shell, yeah? So it's a protective bubble. So inside the shell, it's normal conditions.
To keep it from evaporation, you have to do opposite. So you may have to supply a lot of energy to prevent it from evaporation. I think. I mean, we have to calculate that.
Maybe,
very interesting prospect or proposition. Yeah, that's a good one. Because you wouldn't want that to happen. You also wouldn't want the situation like in Event Horizon where you slide into hell. I don't know if you've seen that.
Yes, that's why you calculate your trajectory like Star Wars. So it's more closer to Star Wars than Star Trek. I don't know about Star Wars. So you calculate first your coordinates and then make the jump to hyperspace. But hyperspace is not; it's just a bubble.
Yeah.
It's the immediate environment of the bubble. You're still traveling inside normal vacuum space.
Mm.
And you mentioned about invisible. That's an interesting thing because there could be a lot of space FTL spacecrafts that's going around. We cannot see it. You know, there could be a lot.
Yes.
It's
My
quite
question
possible.
is actually, my question is, even if you have the FTL drive switch off, and you're standing alone with your spacecraft, yeah, and you switch it on, then I say you become invisible. My question is, can you, if you are inside this bubble and traveling at FTL speed, will you go through matter? So there's no problem if you collide with a planet, for example, or you go, as Christopher said, inside the event horizon.
Right. Like a wormhole, like a wormhole. You will go through like a wormhole.
No. Okay, you are inside the bubble. You are protected. You're going to faster than light. You are isolated from the surrounding vacuum, but you still have a displacement volume. So now you're driving with FTL speed through a planet. Will you collide and smash into pieces and be dead, or just go like a neutrino, just straight through inside the matter of the
wormhole?
Planet?
You have to find a wormhole to go through.
No,
like a tunnel.
no, I don't think
no.
that's
In my theory, it doesn't need no wormhole. My theory does not need
I thought you were saying earlier though that you could
That's
just.
My question. That's my question.
Oh yeah. Would you need more energy to go through a planet than you would just normal space?
But the question is, if you are displacing the vacuum, actually you are in a different phase altogether. So you may not collide with the planet because you are in a totally different phase. You are not in subluminal level. So you are the superluminal thing. In that one, there is no planet. There is no real other things that is going to go against. I mean, that's my feeling.
So it will be even better than Star Wars. You don't have to calculate the coordinates to avoid any planets.
If it's called the evaporation problem, I think we have it.
So you have you when you drive, you switch on your FTL drive. You are clocked like a Klingon. You go faster than light, and you can also go through matter.
Luke Skywalker,
or better than Star Wars, but
Jedi or.
What is it in English? Like we have that saying, "As the crow flies," meaning.
Okay, as the crow flies, straight up without giving any shit about whatever is in front of.
Yeah.
B may be like barracuda, right? L is lizard, B is barracuda.
No, it's meant to be like LB, like lizard beings, and then SB. But I don't think that's right. It's like LD. Entities, or maybe it was LE and SE. That was it. Lizard entities. But then actually it was Saurian entities, and then the L stood for something else. It was like little entities. I can't remember, but it was the Greys and the aliens. Yeah, you're right. It was just a code for them for some.
So yes, if they have a directive like Star Trek, this more advanced civilization, they will not come in contact directly with us. So they will be disguised or invisible with their spacecraft.
That makes
sense. Only occasionally we see this. Once in a while we see a UFO and so on.
Yeah, they cannot communicate because you said like a bubble. There is a bubble, so there is no way the communication can reach them. So even if they're aliens, they cannot communicate with us. We cannot communicate with them.
Well,
they don't want to communicate. They don't want to communicate with us.
Yeah.
No, exactly. Yes. Well, I mean,
so they can switch off.
But
so they will suddenly come, switch on, and then see the thing, then switch it off and go back. So there is no enough time to detect.
Well, I don't know. If they're traveling at faster than the speed of light, they have all the time, don't they, in the world? Which is Arthur C. Clarke.
But how do they know where they are going? See, how do they get information? You have to get information. Suppose you are going there. You have to get information. You are going to another galaxy. You have to get information about that. How do you get that?
It's like we're 5 minutes away from our destination, 3 minutes away. That kind of
longitude. How do you get a latitude, longitude, some GPS type of
thing?
Well,
if we take for reference the Star Wars or the movies, they have a sub-channel superluminal communication. I don't know what is this. What does it mean?
Some leak, some kind of a leak. Yeah. So you have to find some kind of a leaking mechanism. that it gives like a diode. So you say, okay, you switch on the diode, so it will transmit. Then you switch off and then switch on the diode in the opposite direction, so it will get the information. So you switch on and switch off a diode.
Yes, maybe.
Oh, what
So
I was thinking, you need some sort of like device that opens a channel through the whole subspace and then send a signal through that. But then, what medium is it?
Yeah, remember also what I told you about the two types of waves. You have transverse waves, which are the actual quantum, the gravity fields, the electromagnetic fields. But you have also this in the superluminal vacuum. You have this longitudinal radial waves. Maybe that's the communication they're using there, because this is instantaneous.
Yeah, yeah,
Maybe
communication.
They're using this kind of longitudinal waves axial waves to communicate. That's the
yeah. You said the graviton. They make this electromagnetic, that the flux line. So you can create a flux line, right? You're saying the flux line, because the gravitons are like this. You're going, so you have a flux line. So you can create a flux line. The flux line will give the communication. It's like the wire for communication.
Rajan, they actually pay, a static field has no time. It has infinite speed, but that's why it's static.
Because
so the Coulomb force, there are papers of people that are saying that the Coulomb force is instant force.
Instant, yeah. Like Newtonian gravity will not work.
The electrostatic force.
Yeah.
That's right.
Newtonian gravity is instantaneous. Yeah.
Because
so it is infinite.
You have, if you have the web of the spider web and you poke it, you make a transverse wave that goes with the speed of sound in the wave, yeah. But you have also a torsion field. So you imagine each fiber, each thread of the web, of the spider web, has also a torsion.
Yeah.
You can twist it. So this kind of information goes much faster than the.
We are talking with Christopher about torsion field.
This goes with the sound speed. The torsion field goes with the sound speed, but the web vibration, the transverse, goes to the much slower. It's not the sound speed.
Yeah, Sakarango waves.
Yes.
We are talking about Sakarango.
This kind of communication. That is also what I was explaining to Christian. Yeah.
So it is like coupling, proper coupling. If you have proper coupling, you can do that. So you can connect you have to find a proper coupling, then you can do the communication.
Yes.
You need a coupling thing. Yeah.
Okay, cool.
Interesting, very interesting.
Yeah. That was really interesting to talk. We got through a lot. I'm glad we also got this.
Sorry for not participating lately to your conversations, but I was very busy with my paper.
Oh, thank you.
My daughter had here, I don't know how you call that. In order to go to the university, you have first to do exams. Here in my country, in the four
geology,
maths, chemistry, physics, and language, Greek language. And we call that